Hi there, my name is Matthew Beaumont, and this is Learning Yi 2, a video course by Pact Publishing. I've developed hundreds of websites and web-based applications using the LAMP stack for a variety of clients over the past 8 years, and for 5 of those years, I've been using the Yi framework. I've created custom content management systems, e-commerce platforms, and even a large-scale recording catalog for the University of California using Yi. I also published an article for SitePoint.com to help announce version 2 of the framework and demonstrate some of its key features. This video will serve as a comprehensive introduction to version 2 of the Yi framework, which will help you create secure, flexible, and scalable web-based applications. Version 2 of the Yi framework was released on October 12, 2014, and is a total rewrite of version 1. Yi 2 was developed in order to take advantage of programming practices and tools that weren't available in 2008 when version 1 was released. If you have experience with Yi 1, then some of the concepts discussed in this course won't be completely foreign, but you will learn how the framework's authors implemented them using modern tools, such as Composer and Codeception. Throughout this course, we will demonstrate the various features of Yi 2 in order to craft a foundation for a dating site for a very underserved portion of the population: monsters. Before we get into the guts of the framework, we will learn how to set up a virtual server on our PC, and then install the Yi framework on that server. Then, we'll learn the basics of configuring our application. Afterwards, we'll take a look at some of the tools that Yi provides to speed up the development process, but without sacrificing quality. In addition to code scaffolding and debugging tools, we'll look at how Yi integrates closely with Codeception to generate automated tests for our application, because no one wants to see what happens when Medusa's profile picture gets cropped incorrectly. Once we've done that, we'll move on to the nuts and bolts of our dating site by creating our first monsters and learning how to create a safe environment for them to meet their soulmate. Then, we'll try to make our application less beast and more beauty, as we look at how Yi handles front-end assets. Moving right along, no dating site is complete without a way to search for matches. So we'll see how Yi handles database interactions, and then look at a few ways to spruce up our search interface. Finally, we'll look at a few tools that Yi offers to help our undead bachelors and bachelorettes put their best face forward, such as image manipulation, email integration, and internationalization. And if you've ever seen a first date between a vampire and a werewolf, you know they can use all of the help they can get. By the end of this course, you should feel comfortable using the Yi framework in your own projects. You don't have to have any experience at all with the Yi framework to learn from this course, but you should have a pretty good grip on the fundamentals of object-oriented programming, and PHP in particular. So if you think Frankenstein and the Wolfman deserve to find true love as much as the rest of us, and you want to help them succeed, let's get started. Hello, and welcome to Section 1, Introducing Yi 2. In this section, we will set up the development environment for our application, install the Yi Basic Application template, learn how to navigate the directory structure of the template, and finally learn the basics of configuring our application. This is the first video of Section 1. It's called Creating a Development Environment. It explains the process of creating a virtual development server on our local PC using VirtualBox, Vagrant, and Puffit. In this video, we will download the software required to create our server, learn how to properly configure it, and finally boot up our server for the first time. In case you were wondering, we've chosen these particular tools because they're all free, they work well together, and are easy to use. Even if you prefer different virtualization software, we recommend you use these tools for the duration of this course because many of our examples are designed to work in this environment. The first step is to download VirtualBox, which will allow us to create a self-contained Linux server that can be easily started, suspended, and destroyed with just a few simple commands. For this course, we're going to install a CentOS guest machine on a host running OS X Yosemite. Open your browser and go to www.virtualbox.org. Click the Downloads link to download the appropriate version for your machine and run the installation binary. In VirtualBox, the virtual server is referred to as the guest, while the machine running VirtualBox is called the host. Next, we're going to download Vagrant, which makes it possible to configure our guest machine using text files. Go ahead and visit www.vagrantup.com. Click the Downloads link, and once again download your system-specific installer and run it once your download is complete. After Vagrant is installed, we'll use Puffit to generate the configuration files needed to create our development server. Go to puphpet.com and start off by telling Puffit that we're going to install our server locally. Tell Puffit that we're going to use VirtualBox as a provider, and then select your favorite Linux flavor. We'll use CentOS. We can leave most of these next options set to their defaults, but please note our guest machine will be using the IP address 192.168.56.101. We'll also set up forwarding for MySQL on port 3306, which we'll need later when running automated tests. One thing that Vagrant helps us do is sync files between our host and guest machines, so we can edit files on our host machine using our favorite IDE, and the changes will instantly be reflected on our server. So let's go ahead and tell Puffit to sync our local packed code folder, which is located in our home directory, with the web root of our server. Now, click Packages and tell Puffit that you'd like to install Vim, which we'll use to edit some configuration files on the server. We'll also need to add PHP-XML so our unit tests will run properly. Next, click Firewall Rules and create a rule to allow traffic through port 3306 from MySQL. Moving on, we'll set up our web server. Check Install Apache. We will access our application using the domain monstermash.dev. We can also get rid of this server alias over here. Also, we need to tell Apache that it can locate our files in the web subdirectory of the monster mash directory. Now, we need to install our server-side scripting language, which is of course PHP. As long as we're using PHP 5.4 or higher, our server will be able to meet Yi2's minimum requirements. We also need to add the MB string and iMagicK extensions as Yi requires them. At this point, we have our operating system, web server, and server-side scripting language configured. The last piece of the puzzle is our database. Let's go ahead and use MySQL. We'll change our username to something more appropriate for this application. And while we're at it, let's rename our database. Finally, we'll grant our new user access to all databases. Now that we've got everything configured, all that's left to do is click Create Archive, and then click on the oversized download button in the middle of the page. Puffit unpacks its files to a very unmemorable folder name, so I suggest renaming it to something a bit easier to remember. You should note that we've also included a copy of the Puffit files in the course code samples if you'd like to make sure we're all using the same server configuration. Now, we're ready to start our server. Change to the directory that contains your Puffit configuration files, and simply type Vagrant up. Go grab a coffee, and in about 10 minutes you'll return to find your brand spanking new server ready to use. So far, we have learned how to create a virtual server on our development machine. This will come in handy as we install the Yi framework and begin to code our application. In the next video, we will learn how to install the Yi2 basic application template, which is the starting point for most projects that use Yi2 as a development framework. Hello again. Welcome to video 1.3, Installing the Basic Application Template. In our previous video, we learned how to create a virtual development environment on our local PC. Now we will use the Package Manager Composer to install the Yi2 basic application template, which will be used as a starting point for our project. Then we will configure our web server, in this case Apache, and our local development machine so that we are able to access our project using an easy-to-remember domain name. Finally, we will verify that our application template was successfully installed. The first thing we need to do is switch to our terminal window and connect to our server. If you aren't still in the directory where your Puffit configuration files are located, switch there now. Next, I'll log on to the server by typing vagrant SSH. Next, we need to change into our web root and delete the web subdirectory that Vagrant created for us. Yi will reinstall it in a moment. Now we can use the popular PHP Package Manager Composer to install the Yi2 basic application template. But before we do this, we have to install the Composer Asset plugin, which allows Yi to easily manage front-end assets, such as CSS and JavaScript, without installing Node Package Manager and Bower. We will tell Composer that we need to install our package globally. The name of the package is fxp/composer-asset-plugin, and the version is 1.0.0. Finally, we can install our template. We'll tell Composer to create a new project, and tell it that we'd like it to use the latest stable version of Yi 2. The package name is yisoft/yi2-app-basic, and we want to install it in the current directory. Press return, and Composer will download and install all of the files we need to get started. The basic application template is provided with the course code samples and can be installed using Composer install. Apache knows to serve our new project in response to requests for monstermash.dev because we told Puffit to use that domain name. But because we didn't register monstermash.dev with a domain name provider, our browser won't know how to resolve it. In order to fix this, we need to add an entry to our system's host file, so it knows to direct requests for monstermash.dev to our virtual machine's IP address. Now, if we try to load our site using monstermash.dev, we'll see that Yi is congratulating us for accomplishing our goal. We've now successfully installed the Yi 2 basic application template. In the next video, we will take a closer look at the files and directories that make up our new application. Welcome to video 1.4, Overview of the Yi 2 directory structure. In the previous video, we learned how to install the Yi 2 basic application template. In this video, we're going to take a closer look at the files and directories that make up the basic application template. First, we will walk through each directory and give an explanation of what files they contain. Then, we will explore how Yi uses namespaces to allow its autoloader to quickly find the files that our classes will depend upon. The first thing we'll do is go ahead and open the monstermash directory in our IDE. If you look at the left side of the PHP Storm application, you'll see all of the folders and files that make up the Yi 2 basic application template. Let's walk through each of these folders and discuss their role. First up is the assets directory. You'll see that this directory contains a file called appasset.php. We'll discuss assets in more detail in section 5, but in short, this file is used to define the front-end assets, such as stylesheets and JavaScript, that your application will use. Next, we'll move over to the config folder. We'll discuss application configuration in more detail in the next video, but for now you just need to know that all of our configuration files are stored in this directory. As you may know, Yi is an application framework that implements the MVC, or Model View Controller pattern. We'll talk more about the specifics of Yi's implementation in the second section of our course, but as you can see, we have a controllers folder, a models folder, and a views folder, and each of those contains objects of that type. Moving on, we'll look at the tests folder. Testing will be explained in great detail in section 3. Yi uses the Codeception testing framework for its automated tests, and this is the directory where you will store those tests, as well as the Codeception configuration files. The vendor directory is where Composer installs all of your project libraries, including the Yi framework files. You won't typically interact with this directory manually, as Composer handles this for you. Let's take a look at the web directory. As we saw in the last video, this will serve as the web root of our project, and it's where Yi stores all of your front-end assets, as well as its own entry script, index.php. All incoming requests will be routed through this script, which is quite basic as you can see. It simply loads the framework files and autoloader, as well as your application configuration, and then uses that configuration to create a new application instance. You may notice that we skipped a few folders: commands, mail, and runtime. The commands folder contains console-based script. Mail is where Yi stores templates for HTML emails. And runtime is where Yi stores its debug data and application logs. Finally, let's take a look at namespaces in Yi. Namespaces follow the PSR4 standard. Let's open one of the classes in the basic application template and try to understand what's happening. Open the controllers folder and click on sitecontroller.php. The first line that you'll see is the namespace declaration. That tells the autoloader where this class is located. Please note that in this case, app is an alias to our project's root directory. Next, you'll see some use statements, which allow us to use shortcuts to our dependent classes in our site controller code. For instance, you'll see use app, models, contact form. If we scroll down to line 79, we can see that we instantiate a new contact form object. The use statement that we saw earlier tells Yi's autoloader to look for that class file in the models subdirectory of our application root. And sure enough, when we open the models directory, we can find the contact form class, which is under the app models namespace. For more information on the PSR4 standard, visit www.php-fig.org/PSR/PSR4. Yi defines several aliases to make life easier. For instance, Yi refers to the framework directory, while web refers to the directory containing your index.php. A full list can be found at www.yiframework.com/doc-2.0/guide-concept-aliases.html #predefined-aliases. At this point, you should feel comfortable finding files in the basic application template. You should also know how to tell Yi's autoloader where to find dependent classes using namespaces. Next, we will figure out how to configure our application and extend its core components in order to add to or modify their existing functionality. Welcome back to video 1.5, Configuring and Extending Yi2 Components. Last time, we explored the file structure of the basic application template and learned how to use namespaces to help Yi's autoloader find our class dependencies. Now, we will take a look at how we can configure our newly created application. First, we will look at how we can change some basic settings, including the application parameters and database connection settings. Next, we will learn how to configure a core component of the Yi framework to change how our application handles URLs. Finally, we will extend a core component to add desired functionality to our application. The first step is to open up our config directory. Let's open up web.php, which is our main application configuration file. Ignoring the first line for a moment, you'll see that this file defines an associative array called config and returns it at the end of the script. If you remember our index.php entry script, it included this file and then fed its output to the application object as a constructor parameter. Essentially, the keys in these array values map to public attributes of the component classes that Yi uses during the application lifecycle. For instance, if you look at the mailer section of the array, you'll see that the value of useFileTransport is set to true. If we open the base mailer class, which the mailer class inherits from, we'll see that useFileTransport is a public attribute of that class. If we head on back to web.php, we'll see that before the config array is defined, Yi sets another variable called params. The values for this file are set in params.php, which is located in the same directory as our current file. Let's go ahead and open that up right now. You will see that this file simply returns another associative array. You can use this array in order to set application-wide variables. Now that we understand parameters, let's configure our database. The database components are also added to the config variable by including the external file. Open that file. Go ahead and update this file to match the values that were created when we set up our server with Puffit. Next, we're going to change the default behavior on Yi's URL Manager component, which among other things determines how Yi interprets incoming URL requests. Open our application and click on the About menu. You'll see that our URL looks rather unfriendly and unmemorable. Head back to web.php and add a URL manager section. Next, set Enable Pretty URL to True. Switch back to the browser, reload the page, and then click the link again. That's certainly looking better, but wouldn't it be great if we could get rid of this index.php? And if you ever saw a merman try to type, you would know why. This is a two-step process. First, we'll go ahead and add another setting to the URL manager section of web.php called show script name, and we'll set it to false. The second part is to add an htaccess file, which will tell Apache to route all requests for non-existent files and directories to index.php. Create an htaccess file in your web directory containing the following code. Now, switch back to the browser one last time, reload the page, and click the About link again. Great! Isn't that much easier to read? Okay, so we've learned how to configure an existing application component. But what if we want to extend the functionality of one of these components? We'll talk more about Yee's View component later, but for now, just know that it is responsible for the display layer of our application. It has a render method, which it uses to generate content. Well, let's say we wanted to filter out the word garlic throughout our application, because some of our users have reported an extreme sensitivity to it. Let's edit the content of our About page, which is stored in Views, Site, About.php, and add some objectionable content. If we load our About page, we'll see that it shows up right where we expect it to. A good habit to get into is storing your custom components in a components directory, which doesn't currently exist. So let's go ahead and create one in the application root. Now, create a file called view.php and add the following code. We make our namespace declaration and extend our new class from the current view component. And then we override the existing render method, but we filter the word garlic before returning its value. This would be a good time to point out that this is a rather crude way of filtering our content. Yee provides formatter-helper objects to accomplish this task in a more modular fashion, but we're just trying to grasp the concept of overriding core application components, so this will do for now. So our updated render function is all set, but we have to tell Yee to use our custom view component rather than its built-in version. In order to accomplish that, we head back to web.php and create a view section. Add a setting to this called class and set it to app components view. Now, when we take a look at our About page, we can see that our unwanted content has been replaced by its censored version. This should be great news to both you and the lonely vampires who will be using our site. That's all. That brings us to the end of the first section. We now understand how to configure Yee and its components, as well as extending them to add to or modify their default behavior. In this section, we also set up and connected to a virtual development server. We then configured that server and installed the Yee basic application template. Next, we took a closer look at the files and directories that make up the basic application template and learned how to use namespaces in Yee so that the autoloader can quickly find dependencies. In the next section, we will take a look at some of the tools that Yee 2 provides to greatly increase productivity during application development. Hello again, and welcome to Section 2, Introducing Yee's Development Tools. In this section, we will learn how to use Yee to generate code templates for our models, views, and controllers. We will also take a look at the Yee debug module. So let's move on to the first video of this section, Configuring and Using Yee. We'll take a look at exactly what Yee is, why we will want to use it, and how to configure it. As you may already be aware, Yee implements the model view controller pattern. When using an MVC-based framework, developers often spend a lot of time copying and pasting common code, and then editing it to meet the requirements of a specific application feature. This process is both time-consuming and error-prone. With Gi, we can use a web-based interface to quickly generate model, view, and controller code that is tailored to our needs. Once we get Gi configured, we'll go ahead and take a brief look at its features. As you can easily imagine, a tool that can generate code on the server represents a security risk in the hands of unauthorized users, so Gi's authors wisely chose to require us to explicitly set some configuration options in order to access it. The Gi tool is located in the Gi subdirectory of your site. But you'll see if we try to access it that we get a 403 forbidden error. That's because Gi only allows requests from localhost by default, but because our application is running on a Vagrant server, our host and guest machines use separate IP addresses. In order to allow access to Gi, we simply need to add the IP address of our host machine to the Gi configuration. To find your host machine IP address, create a new file in the web root called ip.php and echo the remote address value of the server superglobal. If we pull this script up in our browser, we'll see that our IP address is 192.168.56.1. Remember to delete this file before moving to production. Now, we simply need to add this IP address to our configuration. Go ahead and open up web.php and scroll down to line 59. You'll see that this section of the config is wrapped in an if statement that only runs if the site is in development mode, which is another layer of security so that Gi will be totally inaccessible in production mode from any source. Simply edit the configuration section as follows in order to add your IP address. Now, switch back to your browser and reload Gi. You'll see that we're greeted warmly by the magical tool that can write code for you. On first glance, you will notice that Gi can be used to generate models, views, and controllers. It can also be used to quickly scaffold out forms, modules, and extensions. In this course, we will use the model generator as well as the CRUD generator to generate the bulk of the code for our application. Now you know what Gi is and how to set it up. Up next, we will look more closely at the process of generating model code, as well as some of the key features of models in Gi 2. Hello, welcome to the second video of Section 2, Generating and Working with Models. In the previous video, we learned how to configure Gi's code scaffolding tool, Gi. Now that we can access it, we'll use Gi to generate a model based on a sample database table. Then, we'll take a closer look at Gi 2's models and how they help you manage your application's data. Then, we'll look at how you can retrieve specific models. Finally, we'll learn how to validate, save, and delete models. As you probably already know, models are the part of your application that are responsible for representing and manipulating data. We'll use a simplified version of our monster table in order to clearly demonstrate Gi's model features. Go ahead and use the database management software of your choice to run db section2.sql from the course code samples on the Monster Mash database on your Vagrant server to create our test table and populate it with some sample data. Head back to Gi and click the Start link in the Model Generator section. One of the first things you may notice is that if you roll over any of the underlined text, that Gi will give you more information on what you're expected to provide in each text box, which can come in very handy. Begin to type monster test in the table name box, and you'll see that Gi auto-completes the table name for you. Next, the model class is typically a capitalized version of the table name. And that's it. Click on Preview, and then click Generate on the next page. Now, let's take a look at what Gi did for us. Head back to your IDE and open Models, monstertest.php. You'll see that Gi created a class that extends from Gi DB ActiveRecord, which we will look at more carefully in just a minute. You can see how the code has been tailored to our table name and columns. ActiveRecord is the name of Gi's ORM, or Object Relational Mapping implementation, and if you've ever worked with Ruby on Rails, you'll find yourself in familiar territory. It provides functions to load, create, update, and delete data from your application. Typically, one row in the database relates directly to a single instance of a model object, and the value of each column becomes a property of that same object. In order to load models, you will use ActiveRecord's Finder functions. To keep things simple, we will put all of the test code in this section on the About page that we edited in the last section. Open up Views, Site, about.php. You will see that a use statement has been added to allow the autoloader to find our monster test class. Further down the script, you will see several examples of active records finder methods. The find1 method takes the ID of the associated record as a method parameter. So when we echo its name parameter, we get the expected result of Dracula. Similarly, the findAll method returns an array of active record objects matching a set of conditions. In our example, we are looking for all of the male monsters. Based on our sample data set, we should expect to find 3. And if we look at our script's output, we will see that we do. Next, we'll see that active record allows us to validate data before writing to the database. In our sample table, age was defined as an integer, and gender is a string with a length of 1. If we look at the rules method of our monster test class, we'll see that Guy generated corresponding validation rules for each of these database requirements. You can see that we've created a new monster using some data that violates these rules, and attempted to write this object to the database using the save method. Looking back at our About page, you will see that the monster tests object's getErrors method returns an array of appropriately worded error messages with the attribute name as a key. However, if we feed our monster object valid data and then run the save function, we'll see that our error array is now empty. And if we look at the database, we'll see a new row with our valid data. Finally, we can use ActiveRecord's delete method to remove a row from the database. You'll see here, because the find1 method returns an instance of the monster test object, that we're able to use method chaining to call the delete method. Now if we look at the database, we'll see that our new Wolfman record is gone. Isn't this great? Without writing a single line of code, Guy has created an object that makes interacting with the data layer of our application a breeze. In the next video, we'll discuss the next piece of our MVC puzzle, controllers. Welcome to the third video of this section, generating controllers. In our previous video, we learned how to generate models using Guy, and then explored some of their features. Now, we're going to do the same thing with controllers. We'll use Guy's CRUD generator to create controllers and views for our monster test object, learn how to tell what controller is being used on a particular page of our application, and then understand some of the common tasks that controllers perform. Go ahead and open up Guy again, and click the Start button under the CRUD generator. Most of you will already know that CRUD is an acronym for Create, Read, Update, Delete, which are the 4 common actions one would perform on data in an application. Guy allows us to generate all of the code to do this with a single click. Our model class is App, Models, Monster Test. The model search class is something that we explore in more detail in a later section, but for now, the convention is simply to append search to the model name. Same thing goes here for the controller class, except that the suffix here is controller. The view path will sort itself out, so go ahead and click Preview, and then Generate. Guy will tell us that it has created 8 new files for us, all with one click. Isn't that great? Before we look at our generated code, let's talk for a second about what a controller does. Generally speaking, controllers are the place in your code where you will load and save models and provide data to your views, which we will discuss in the next video. Also, controllers are typically the place where you will process user input if there is any. But how does your application know which controller to load? By default, it comes from the URL. For instance, in the last few videos we worked on the About page, and the URL for that was site about. If we open the controllers folder, we see a site controller. If we open that file, we see a method called actionAbout. This is the method that Guy calls when you access site about. And in this case, it has a single purpose, to load the About view using its render method. And if you remember, when we went to edit that page, we logically went to Views, Site, About.php. Now that we understand the basics of controllers, let's go ahead and open up our new monster test controller. You can see that there are several actions, and each one of these can be accessed by navigating to the corresponding URL. For instance, if we take a look at the action index method, we will see that we should be able to access something at monstertest/index. And we can. Just so you know, you can leave out the index part if the method is action index, as it is assumed when no action is provided. If we look at that method, there is a lot going on. For now, all you need to know is that the method is creating a new monster test search object, which is used to get a filtered array of monster test objects. The second line takes user-supplied search parameters and feeds them to the monster test search object. We've already seen the render method, but in this case it has a second parameter, which is an associative array. Each item in this array is an object which the controller has created and is now passing into the corresponding view script. So for instance, the search model variable that was created in this controller will now be available in Views monster test index.php as a variable called search model. Controller actions can also take parameters which are passed in via the URL. For instance, click the eye icon in the first row, and you'll see that we are brought to monstertest/view?id = 1. If we take a look at the action view method, we will see that it takes a single parameter called id. It is fed to the findModel method at the bottom of the controller, which simply calls find1 in order to load a model with the corresponding ID, or throw an exception if no model is found with that ID. Eventually, that model is passed through to Views monster test view. Finally, let's take a look at a slightly more complicated controller method, action update. As we can see in our browser, this page creates a form which is pre-populated with the current attribute values of our friend Dracula, and upon submission updates those values in the database. If we look at the action update method of the monster test controller, we'll see the first thing that it does is load the proper model based on the ID parameter specified in the URL. Next, it checks to see if the form was submitted, and if so, it feeds the values from that form into the model, and then attempts to save it. If the form is valid, the controller redirects us to the view action, and if not, or if the form wasn't submitted, it loads the update page. So now you've learned how to easily generate all of the code you need for your controllers and taken a closer look at the part that they play. In the next video, we will complete our MVC puzzle by taking a closer look at views. This is the fourth video of this section, generating views. Last time, we explored the controller code that Guy created using its CRUD generator. In this video, we will look at many of the same application features as in the last video. However, this time around we will focus on the view layer. More specifically, we'll look at generating views, introducing views, and registering tags and assets. Simply stated, views handle the presentation layer of our application. In other words, they are responsible for the way our application looks. The majority of code in our views will either be straight HTML or PHP which generates HTML. Let's return to our monster test listing page, but this time we'll look at the view code to see how it generates our application HTML. In order to do that, let's look at the HTML source so we can see the relationship between some of Yi's view methods and the presentation code that it generates. Go ahead and open up Views monster test index.php. You'll see that Guy has kindly provided some code comments, which help remind you of some of the variables available in this view. You'll see that this in the view context refers to the application view component. Next, you'll see two variables, named search model and data provider respectively. You may remember from our last video that these are the two variables that our controller's action index method provided as a method parameter to its render call. These code comments will be helpful to many IDEs in order to take advantage of code completion. Next, you'll see that this title is set to monster tests. If you look at the page source, you'll see that Yi outputs a corresponding title tag for you. If we change it to something else, for instance, learning Yi 2 monster tests, and then reload the page source, we'll see that our page title has changed accordingly. Further down the page, you'll see several uses of the HTMLHelper, which we will cover in more detail in Section 5 of this course. For now, Just know that the first call encodes any special characters, and our page title is HTML entities, and the second generates the link tag found on line 29 of our HTML source. Finally, you'll see a call to the grid view widget, which we'll explore in detail later in section 6. However, even without knowing the details of how this works, you can see that the data provider and search model variables are fed as parameters to the widget method. Additionally, you can see that the values passed into the column setting are used to generate the 4 data columns on our monster test list page. In order to confirm that this is what's happening, let's comment out the ID column, switch back to our browser, and reload. We'll see that the ID column has disappeared. The view component also allows us to register meta tags on an individual page. This is achieved simply by using the register meta tag method. It takes an array as a parameter with the name and content of the meta tag. We'll create a description meta tag with the content, "This is my first Yi application." Save the file, switch back to the source, and you'll see that Yi outputs our new meta tag. Finally, if you need to add JavaScript to an individual page, the view component gives us several methods to achieve this. If your JavaScript is located in an external file, you use the register.js file method and provide the URL of the script. For instance, if we wanted to add AngularJS to our list view, we could simply provide the register.js file method with its CDN URL. By default, the script tag is output at the bottom of the page, just above the closing body tag. If you wanted it in the head section instead, you could add a second parameter to the register.js file. This parameter can be an array with the key of position. And the view object has several predefined class constants for the various positions of the script. We'll try to move it to the head using posHead. Look again at the source, and we'll see that our JavaScript has been moved to the head section of the page. The view component also provides a method to include CSS files called register_CSS_file. By now, you should have a firm understanding of the role of views in your application and how to use Yi to generate them. In the next and final video of this section, we will take a look at another one of Yi's built-in development tools, the debug module. Hi, this is the 5th video of the second section, configuring and using the debug module. In our last several videos, we learned how to generate models, views, and controllers using Yi, which is Yi's code scaffolding tool. Now, we'll look at another of Yi's development tools, the debug module. Much like Yi, the debug module needs to be configured before use, and we'll learn just how to do that. Then, we'll take a look at some of its features. Finally, we'll learn how to create our own custom panel. Fortunately, the first step in this process should be pretty simple, as it is identical to configuring Yi. Just go ahead and open up config web.php and scroll down to where we configured Yi. The configuration options are so similar that we will simply copy-paste the Yi configuration over the debug configuration, and then replace references to Yi with references to debug. Now, head back over to your browser and reload your application. You'll notice something new and unfamiliar at the bottom of the browser window, the debug toolbar. Just by looking at the toolbar, you can see that we now have access to a wealth of information about our app. From left to right, you can see that it tells us what version of Yi we're running, what version of PHP we're running, the HTTP response code for the current page, the current route, the number of log messages for the current page, the amount of time it took to process the current script, the amount of memory the current call required, the number of database queries, and the combined time it took to run them, and finally the number of asset bundles loaded on the page. Clicking on any one of these pieces of information will bring us to a page with more detail. For instance, clicking on the database portion of the toolbar brings us to a view that lists all of the queries that were run in order to generate this particular page, as well as their execution time and query type. Clicking on items in the left navigation panel reveals a host of valuable information about each page that you can use to track down performance issues and squash bugs. The top navigation allows you to view similar information for previous page requests. Hopefully it is becoming apparent how invaluable this information can be in writing quality applications. But what if you need information that isn't included by default in the debug module? Fortunately, it is reasonably easy to create your own panels and seamlessly integrate them into the debug module. For instance, it might be helpful to have a panel that tells us what monsters are loaded from the database during a given request. Go ahead and open up panels monsterpanel.php, and you'll see that we've created a new class which extends from the base debug panel. The init method is run before each and every controller action. The method's contents are a little advanced for us at the moment, but in a nutshell, they simply tell the panel that anytime a monster test object is loaded, using a finder function to add it to a private variable called monsters. The getName method simply returns the name of our new panel. GetSummary returns the total number of monsters as well as the URL for the detail page of our new panel. This is how the debug toolbar at the bottom of the page gets its information. The getDetail returns our detail data in an HTML formatted list. In the previous two methods, we saw references to this data. The save method is what converts our monster's private attribute into the data used by the debug toolbar. The last thing we need to do is tell the debug module to use our new panel. So switch back to config web.php and add a panel section to the debug config. Then, tell the debug module where to find our new monsters panel. Let's head back to our About page, which we previously used to demonstrate monster test finders. Already, we can see that the debug toolbar at the bottom of the site has a new section, Monsters, and it tells us that 4 monsters were loaded during this request. If we click on this part of the toolbar, we're brought to a new panel detail page, which shows the names of each of the monsters which were loaded during this request. Nice work! Now that we've come to the end of this section, you should feel comfortable using Ghee to generate code templates for your application. You should also feel like you have a good understanding of the role of these templates in relation to the overall application structure. Furthermore, you also learned how to use the debug module and even create your own custom panel. In the next section, we will look at how to use Codeception, which is a PHP testing framework, in order to help confirm that our application is functioning as expected. Welcome back to Section 3, Testing with Ghee and Codeception. In the previous section, we learned how to use Ghee's built-in development tools, such as Ghee and the debug module. In this section, we will learn how to write automated tests for our application using the Codeception testing framework, which ships by default with the Ghee 2 basic application template. We will learn how to configure Codeception and then use it to write unit, functional, and acceptance tests so we can feel confident that our applications work as we intend them to. This is video 3.1, introducing the Codeception testing framework. In this first video, we will learn what Codeception is, and how it will take a lot of the tedious work out of writing automated tests for our application. We'll start off by introducing Codeception and the basic concepts of application testing. Then we'll learn how to configure Codeception. Finally, we'll learn how to provide our tests with sample data. There are 3 types of automated tests that developers write: unit, functional, and acceptance. We will take a closer look at each type in the subsequent videos, but it will be helpful to understand the differences between the 3. Unit tests are used to confirm that individual units of your application are functioning as expected. In Ghee, this will typically be model and component classes, and these tests will confirm that their public methods function as expected. Functional tests aim to test your application as a whole using a browser emulator, which in the case of Codeception is PHP Browser. They will load your pages and verify that they function as expected, but will do so programmatically. They can interact directly with the database and submit form data directly to your server-side scripts. By contrast, acceptance tests use an actual browser to test your pages. They actually click buttons and links, enter data into forms to trigger validation errors, and can even be used to test JavaScript functionality. Codeception provides helper classes for each of these 3 types of tests, each of which has methods that can make writing your tests much easier. In order to get started with Codeception, we'll go ahead and connect to our Vagrant box using Vagrant SSH. We need to use Composer to install our package. We'll do that globally, and the package name is Codeception/Codeception, and the version number is 2.0. While that's installing, you'll also need to add the Composer global binary package directory to your path so that you can run Codeception globally. In order to find that directory, type Composer global status and note the directory that is returned. Next, edit your path, which in our case is located in the bash profile file of your home directory. Type in the directory that was returned in the previous step, and then add vendor/bin. Save the file, then type source home/bash profile, and then you'll be able to run the Codeception command from anywhere on your system. Now, you simply need to tell Codeception to build its helper classes. Switch to the tests directory and run the build command. It builds one class in each of the test suite directories based on the configuration YAML files in the test directory. For instance, if we look at the functional suite configuration, it tells Codeception to include the file system and ye2 modules, which contain additional methods for your functional tests. If you open up the generated functional tester actor class, you'll see that it extends from the base actor class, but includes methods from the file system and ye2 modules. The final thing that we'll look at in this video are fixtures, which are used to populate a test database so that you have fixed data to test your code. The first step is to create a test database. Using your database management software, create a new database called monstermash-test. Now, edit tests config.php and update the database name to monstermash-test. Next, we'll need to set up the schema for our database. Open db section3.sql from your code samples and run the query on your test database. The schema should look very familiar, as it is the same as we used in the previous section. Now, we need to create a fixture class and provide it some data. First, open up tests, Codeception, fixtures, monstertestfixture.php, and you'll see that a fixture class simply tells our testing suite what model class our fixture will be an instance of. Next, open up tests, Codeception, fixtures, data, monstertest.php. You'll see the script simply returns an associative array with properties and values for some test monsters. Now, whenever we run a test using this fixture, this data will be available in our test database. You should feel confident that you understand what Codeception is and how to get it set up. You learned about the different types of tests that Codeception can help you write, how to configure it, and how to provide it with data in order to create a known state for your tests. Coming up next, we'll take a closer look at the first type of tests, unit tests. Welcome to video 3.2, unit testing. In our last video, we learned what Codeception is, how to configure it, and what it can do to help write automated tests for our application. In this video, we are going to focus on the first type of automated test, unit testing. We will learn what unit tests are designed for and when to write them. Then, we'll learn how to load the fixture that we created in the previous video to provide some sample data for our test. Finally, we'll learn to write and run our first unit test. Before we look at our first unit test, it is important to understand what a unit test is and why we might want to write one. Unit tests are named as they are because they are meant to test a single unit of code in isolation. In object-oriented programming, this usually means a single class, and in Ye, it usually means either a model or component class. Typically, when writing unit tests, you only test a model's public API, or more simply put, any function marked as public. This is because you are only interested in testing methods that other classes will be able to access. It is also worth noting that you typically don't test any public methods that either belong to framework-based classes or are generated by Ye, because it is assumed that those methods have already been covered by the framework's own unit tests. Let's go ahead and create our first unit test. We're going to create some new public methods for our monster test model, and we want to make sure they work as we expect. Unit tests go in tests, Codeception, unit models, and are named by appending the name of the class you'll be testing with test. So in this case, our file name is monstertest.test.php. Open it up and add a namespace declaration. All unit tests extend from the Codeception test case class, so add a use statement for that. We'll also need a second one for our actual model class. We'll add a class declaration and extend it from the test case class. There you go. You've created your first unit test. But it's not very exciting yet, so let's go a little further and make it useful. We want to make sure we have some sample data in our test database, which is why we created that fixture in the last video. Codeception makes loading that data a snap for your test. Simply add an appropriately named public method, fixtures, to your new test class. That method will return an associative array, which points to your unit test to the fixture or fixtures that you need to load to run your tests. Now, Codeception will populate the test database with the data from your fixture before each test. Now, let's actually write a few tests. Codeception actually uses PHP unit to run its unit tests. So in a similar fashion to PHP unit, each test is going to be a public method in your class that starts with test. We're going to create a simple method in our monster test class that returns true if a monster is considered old, and false if they aren't. The method will actually be a magic getter function, which is a neat feature of Yi models. We'll call the method getIsOld. But it will actually be accessible as a property simply called isOld. If you attempt to access an object property that doesn't exist, Yi will look for a method that starts with get and ends with a non-existent attribute. At the risk of offending some of our monsters, we'll make the function return true if a monster is over 40. So head back to the test and create a public method called testisOld. We're going to use PHP unit style assert statements to test our method. Before we do that, we have to tell Codeception to include those assert methods in our unit tester helper. Open up tests Codeception unit.suite.yaml, and then add a modules section. Add an enabled key, and then add the value asserts. Switch to the terminal and run codecept build again. You'll actually see that Yi tells us that it included the asserts module in our unit tester class, which provides 19 methods. Based on our sample data, we would expect our application to consider poor Dracula old, but not Miss Medusa. Because these functions return a true or false value, we can use the assert true method on Dracula, which simply marks a test as passed if the method returns true, and marks it as failed if it returned false. Switch to your terminal and run the test. You'll see that indeed the test passes, confirming Dracula's worst fears. However, if we run assert true on Medusa, it should fail, as the isOld method would return false. You'll see that Codeception tells us that one test failed, because false is not true. It's even kind enough to tell us which line number to look for the problem. If we use the assert false method, however, then our test will pass, and everyone will be clear where they stand. At this point, you should have a pretty firm grasp on the basics of unit testing. Coming up, we'll take a closer look at the next type of test, which are functional tests. Hello, welcome to video 3.3, Functional Testing. Previously, we took a closer look at unit tests, and how Codeception helps us to write them to test our Yi 2 applications. In this video, we're going to take a closer look at a different type of test, functional tests. We'll learn the basics of functional testing, how to load fixtures, and how to run functional tests. Functional tests are different than unit tests, because they are designed to test how all of the server-side parts of your application interact with each other. While unit tests focus on a single model, functional tests tend to test an entire page. They use a browser emulator to load a page and test whether your application is outputting the information you expect to see. Codeception's browser emulator is called PHP Browser. Functional tests are also typically written in a language that even non-programmers should easily be able to understand. Because this browser will be interacting directly with the code on your server, we'll run it from inside our Vagrant box. If you aren't already connected, connect to your server. Next, switch to the web root. And use PHP to start its built-in web server, which is available in PHP 5.5 and later, and set it to listen on port 8080. Next, we need to make sure our fixtures are loaded so we have some test monsters to work with. For both our functional and acceptance tests, this requires a special fixture helper class. Go ahead and open up tests codeception _support fixturehelper.php in the code samples. You don't have to worry too much about the details of this code, except to notice that at the bottom we have another fixtures method, which returns the class name of our monster test fixture. Now, we need to tell our functional tests to use this helper each time they run. Open up Tests, Codeception, functional.suite.yaml, and add our new fixture helper class, taking care to include the full namespace. Now, we're going to start writing our first functional test. We can use the Codecept command line tool to generate the base code. There are two different formats for functional tests, septs and sests. Septs use code that closely resemble natural language, whereas sests look more like traditional PHP classes. We'll use septs for our course. This is a functional test, and because we're going to test our About page, let's go ahead and call this monster about sept. Now, open the file we just created in tests, Codeception, functional. You'll see there isn't very much here, but you'll notice that we have a variable called I, which is an instance of the functional tester class. It also states the goal of this test using the want_to method. We can tell it to load our About page by using the onPage method. We wrote a filter to remove the word garlic from our page, so it's reasonable to assume that we shouldn't see that word anywhere on this page. Fortunately, the functional tester has a method called don'tSee. Add that code and run the test. You'll see that Codeception confirms that our filter is working perfectly. Switch back to the test, and let's make another assertion. We did output Dracula's name when we were demonstrating our finder functions, so let's see if it's still there using the adequately named see method. Running the test again shows that it is. Of course, these aren't the most exciting things in the world to discover, so let's go a little further with our test. Open up our About view, and you'll see that we've added a form to the bottom of the page that asks you to enter your favorite monster's name, and then outputs it to the form when it's submitted. We can actually use the functional tester to fill out forms, click items, and test to see if everything displays as expected. You may notice that both the text input and the submit button were assigned CSS IDs. We did that because Codeception makes it easy to reference those items using a CSS selector. Simply provide them to the fill field and click methods, and then add another call to see, and you'll see that our test passes with flying colors. In this video, we learned all about functional testing with Yi and Codeception. We learned how to load fixtures to run our tests, and we also learned how to write our first test, which not only tested the expected output of our page, but even filled out forms and confirmed that our script responded appropriately. In the next and last video of this section, we will take a look at acceptance tests, which are similar to functional tests, but actually go one step further by running our tests in a real browser. Welcome back to the final video in this section. It's called Installing Selenium and Acceptance Testing. In our previous video, we learned all about functional testing, which can be used to test whole pages of our application using a browser emulator. Acceptance testing is very similar, except that it uses a real web browser to run your tests, which allow you to test things like cross-browser compatibility and JavaScript. Because acceptance tests need a browser to run, they will execute on your localhost PC rather than in your Vagrant server, and therefore need a bit more configuration to get running. If your application isn't going to use advanced JavaScript, or there is another reason that you don't feel you would need to run automated tests in a real browser, then you might want to skip acceptance testing. But the advantages often justify the extra effort. And the good news is that once we have our setup complete, the actual coding of the tests is almost identical to that of functional tests, which you've already mastered. So in particular, we'll install Selenium in Chrome WebDriver. We've chosen Chrome for this course, but note that you can also use Firefox or Internet Explorer instead. We'll then run acceptance tests with Codeception, and finally, we'll accept remote database connections with the Vagrant server. The first step in getting our acceptance tests up and running is to install the Selenium WebDriver. Head over to docs.seleniumhq.org/download and download the standalone web server. We've created a new directory in our packed folder called Selenium, and we'll save it there. We also need to download the Chrome WebDriver, which is located at chromedriver.storage.googleapis.com/index.html. Click on the folder for the latest release, and download the version-appropriate file to your Selenium directory, and then unzip it when it's done. Finally, open a terminal window and type java-version. If you already have Java installed, you can skip this step, but if you don't, OS X will pop up an alert prompting you to install it. Once Java is installed, switch to the Selenium directory and run java-jar and then the name of the file that you downloaded. Next, we have to configure our acceptance test suite to use WebDriver in Chrome. Open up tests, Codeception, acceptance.suite.yaml, and comment out all of the PHP browser sections. Then, uncomment all of the WebDriver sections. Change the URL to monstermash.dev, change Firefox to Chrome, and then add our fixture helper. Because we're running the acceptance tests on our host computer rather than our guest server, we have to install some software that we already installed inside of Vagrant. Open another terminal window and install PHP 5.4 or higher, Composer, and Codeception on your local machine if you haven't already done so. We've covered this in previous videos, so we won't do it again now. Keep in mind that most Macs come installed with PHP. Don't forget to add Composer Global Bin directory to your path also. The fixture helper class we installed in the last video will work for acceptance tests. However, because the database actually resides on your Vagrant server, and we're running acceptance tests on our local host, we have to do a little extra work to get that up and running. Open tests, Codeception, config, acceptance.php. You'll notice this file loads the main application configuration files. We can overwrite settings from those files using the blank array at the bottom of this file. We'll add a section to override the database server and name for our acceptance tests. Now, we need to log on to the server and allow remote connections. Open up etc.my.conf and look for the bind address setting. Change it to 0.0.0.0.0. This will force MySQL to listen for remote connections. We also need to comment out skip external locking. Save the file and restart MySQL. You will also have to duplicate your database user. However, change the host to the %, which will allow this user to access MySQL remotely. Now, we can generate an acceptance test with the same command that we did in the last video, with one small change. We're generating an acceptance test rather than a functional test. If you open the file, you'll see it looks almost identical to our functional test, except that the I variable is an instance of acceptance tester instead of functional tester. In fact, if we copy and paste the code from our functional test, we'll see that our test runs and passes without any additional editing. This brings us to the end of section 3. In this section, we learned all about automated testing with Codeception and Yi2. We started with an overview of the Codeception framework, and then looked in detail at unit, functional, and acceptance testing. In the next section, we will finally begin work on our dating site by creating our first users, and learn how to give them a safe environment to look for love. Hello, and welcome to section 4, which deals with creating and managing users in our application. In this section, we'll take a look at the user model that Yi2 provides us with the basic application template. However, you'll probably notice right away that you need more from a user component, so you'll want to know how to extend it and make it more secure. And that's precisely what we'll do in our second video. Then, we'll learn how to register new users. After we've gotten our user logged in, we'll need to have a way to tell our application what pages they can and can't access. For that, we'll learn about the access control filter, or ACF for short. Eventually, though, you'll find that you need more fine-grained control over access to your application's features, and for that we'll turn to role-based access control, or RBAC as it's also known. So without further delay, let's move on to the first video of this section. The title is a bit misleading, because Yi has actually done all of the hard work of creating a default user object for us when we installed the basic application template. We'll take a closer look at the user model and try to understand how it works. Then, we'll take a look at the identity interface, which any user class needs to implement in order to allow Yi to authenticate it. Finally, we will look at the login form class, which is also provided with the basic application template, and is the link between our romantic hopefuls and their user accounts. Let's jump right in and open up the user model that Yi provided us when we installed the basic application template in the first section of our course. It's located in the Models directory. Right off the bat, you'll see that the user model extends from Yi's object class rather than its active record class. This is because by default, the user class doesn't use a database to store any data. Rather, the application's user data is stored in the user's property of the user class. The keys in each array correspond to the public properties of the class. Moving right along, we see a series of public methods. Nearly all of these methods is required by the identity interface, which the user class implements. Each user needs an ID, so that Yi can tell it apart from the other users of your application. The findIdentity method simply returns a user object that matches a provided ID. We'll skip the methods pertaining to access tokens for the moment, as these are only used in a stateless RESTful application, which is beyond the scope of this course. getID simply returns the value of whatever property identifies our user. In this case, it's simply ID, but you could call it whatever you like, as long as you return its value from this method. There are two additional methods in this object, findByUsername and validatePassword. These are methods that allow you to implement logging in with a username and password combination. We'll see more about those in a moment when we look at the login form. And that's just what we're going to do. The login form class is also located in the Models directory. Try to follow along as we see what's going on here. First, we see a series of validation rules. The one that looks odd is the validatePassword method. This is a custom validation, and it runs a method in this class that shares its name. Looking at this method, we see that it calls another method, called getUser, which calls the user class's findByUsername method. Switching back to the user class for a second, we see that findByUsername simply loops through the user's array looking for a matching username, and if one is found, it returns an object with the user data loaded. Then, it simply runs the user's validatePassword method with the provided password, which does a simple string comparison to see if the correct password was provided. If we open the site controller and look at its action login method, we'll see that the login form class has provided post data from our HTML login form using the load method. Then, the controller calls login form's login method, which runs all of the validations, including validatePassword. If everything goes according to plan, it calls the user application component's login method. The user component is part of the base framework code, and the login method registers the user as logged in. It's a lot to follow, and it seems a bit complicated, but it allows for an amazing amount of flexibility, which we will see in the next video. In the meantime, let's see this all in action. Open up Site Login in your browser. First, let's try an invalid username password. You'll see that the error message from the login form's validatePassword method is displayed for us as expected. Now, if we use the combination admin, which is in the users array of our user class, we'll see from the menu bar that our user was logged in successfully. So now, you understand the basics of the user model that is provided with the basic application template and how it can be used to authenticate your application's users. Chances are, though, that you'll want to store additional information with your users, which will require a database. And you'll also probably want to beef up security some, so we'll learn how to do both in the next video. Hello again, and welcome to Warding Off Evil, which is the second video of this section. In the last video, we looked at the default user that Yi2 provides us with this basic application template. Although that user works well for simple systems with a handful of static users, you'll probably want to be able to easily add, edit, and delete users with your application. And that sounds like a perfect job for a database. So we'll move our user data to a database, create a new monster model, and log in. Then, we'll learn how to use Yi's security component to hash passwords in the database to make sure that Frankenstein can't hack into Dracula's account and cause trouble. The first step is to create a new monster table and populate it with data. Go ahead and open up DB, section 4-2.SQL, and run it on your Monster Mash database. You'll notice that this table looks remarkably similar to the monster test table we worked with in the previous section, except that we've added columns for username, password, and auth key. Now, we need data. We've created a console command for this. Console commands are simply controllers that, when invoked from the command line, run PHP code that helps you maintain your application. Open a terminal window and run the ye executable from the command root. The format of a console command is controller/action. So here, it's monster/load-monsters. Press return, and you'll find that our 5 new monsters have been added to the database. Normally, you would use ye to generate a model from this table, and then add some additional code to turn this class into your application user. We've already gone ahead and done some of the work for you, so go ahead and open up models monster.php, and you'll see what that involves. If you remember from our last section, the application user needs to implement the identity interface, and we've gone ahead and done that here. Next, we implemented all of its methods. The one major difference that you'll notice is that our findIdentity method uses an active record finder to load user data, because our application data is now stored in our database. Although it isn't required by the identity interface, we also went ahead and implemented a findByUsername method, which also uses find1. We need to make a few small adjustments to our application code in order to let ye know that our monster class is responsible for user authentication. First, open up config web.php and look for the user configuration section. Change the class value to our new monster class. Then, we'll go to the login form and update the getUser method to use our new monster class. And that's it. Switch back to our browser and open up the login page. Let's log Dracula in using his username, which is fangman999, and his password, which is yummyblood. Behind the scenes, the generatePasswordHash method either uses PHP's crypt or password hash strategy to hash passwords using the bcrypt hashing algorithm. If you're using PHP 5.5 or higher, then it is recommended to use the password hash strategy instead. So that requires a quick update to the site configuration. Create a security section in the application component configuration, then add a password hash strategy setting, and set its value equal to password hash. Okay, that works just fine, but we have a big security problem at the moment. Our passwords are stored in the database in plain text. Fortunately, ye's security component has methods which will help us solve this problem quickly. We'll need to add a method to our monster model in order to hash the password before saving user data to the database. ActiveRecord provides a beforeSave method that runs before the model's save method inserts or updates a row in the database. In order to use it, you call the parent's beforeSave method, and if it returns true, you add your own custom code. So we'll go ahead and we'll call the ye security component's generatePasswordHash method. This method takes 2 parameters: the plain text to be hashed, which is in this case the monster's password, and a cost value, which is an integer between 1 and 13. The higher the cost, the more secure the hash, but the longer it will take to encrypt and decrypt. We'll use 10 for now, but if you find that your user login and creation takes too long on your server, you can consider reducing this number. There is one problem with our beforeSave method that we need to address before repopulating the database. Right now, the password will be rehashed every time a monster is updated, regardless of whether the password is changed or not. This means that ye will rehash the already hashed password, and for us that's too much hash. So let's add a property to our monster called hashPassword, and default it to false. Then, we'll add an if statement to the beforeSave method, so that it only hashes the password attribute if this new property is set to true. Open up commands monstercontroller.php and add a line to the action loadMonsters method right before our save call, and set that property equal to true. Now switch to the terminal, run our terminal command again, and take a peek at the database. You'll see that our passwords look a lot more secure. The last step is to modify our validatePassword method a bit, and instead of doing a direct string comparison, use the security component's validatePassword function. It will take the plain text password from the login form, as well as the hashed password from the monster object as parameters. Switch back to the browser again, and try to log Dracula in, and you'll see that everything works as expected. So that's all for this video. In this video, we learned how to move our user data to the database and then use the Yi security component to hash passwords. In the next video, we'll go ahead and create a registration page so new monsters can join the fun. Welcome to the third video of Section 4, which is entitled Registering Our Ghouls, Goblins, and Vampires. In our last video, we learned how to move our hard-coded user data into a MySQL database and hash password data using the Yi2 security component. In this video, we are going to take advantage of the fact that our user data is now stored in a database and create a registration page so new monsters can sign up for our dating site. In creating this page, we'll learn about some more features of Yi2, including custom URL rules, model validators, and active form. Since you're already an expert with Yi, we went ahead and took the liberty of generating CRUD code for our new monster model and placed it in the code samples for this video. If you think for a moment about what a registration page does, you'll quickly realize that it is used to create new users, which makes the create action of our new monster controller a prime candidate to use as a base for this feature. However, it might be nice if our monsters could access the page using a simpler URL, such as register. In order to do that, we simply need to add a little code to the URL manager component. Open up config web.php and scroll down to the URL manager component, and add a new section called rules, with an array as a value. This property of the URL manager component allows you to define custom routes in your application. So let's go ahead and tell our application that requests for register should be routed to monster/create. Head on back to the browser and try to load our new URL, and you'll see that you're indeed brought to the monster create page. Keep in mind that Yi will check all incoming requests against these custom rules before routing your browser to its defaults, so having too many rules can negatively impact performance. Next up, let's try to add some rational validations on our registration page. For instance, we probably don't want to allow a monster to select a username that is already taken. The unique validator is exactly what we need in this case. Now, try to steal Dracula's username, and you'll see that Yi thwarts our attempts. The next thing we might want to do is enforce a 6-character minimum on our password field. In order to do this, we pass the min option to the string validator. Again, if we try to use a short password, Yi will inform us that our model is not valid. Finally, we know we want gender to be either M or F, so we can use the built-in range validator. The syntax is a little counterintuitive, but the filter is called in, while the option that you pass it is called range. It takes an array of accepted values. Try one more time to enter invalid data, and you'll see that Yi won't let us write bad values to our database. Now it's probably pretty obvious, but our registration page could use a little work. The code for this page is located in views, monster, create.php. We'll take a second to change the page title, which in turn changes our h1 tag. However, the form code is located in a partial view, because it is actually shared by both our create and update actions. So go ahead and open that up, and let's clean up our form a little bit. The first thing that you'll notice is that all form fields are generated using Yi's active form component. It's responsible for generating form fields, populating them with data where applicable, and even formatting and displaying validation errors. The auth key attribute is only needed to meet requirements of the identity interface and will never be directly edited, so let's just delete that line. The next thing we'll do is change one of the form labels to clarify what data we're looking for. By default, Yi labels each form field by capitalizing the column name that it edits. If we wanted to change name to full name without changing the column name in the database, we can simply head over to our model class and edit the appropriate line in the attribute labels method. Reload the form, and you'll see that the label has changed appropriately. Another thing that can be really annoying about forms is not knowing a field's requirement before you submit and receive an error message. For instance, how is Medusa supposed to know that our password has a 6-character minimum? In order to generate these fields, the active form component uses the field method, which in turn returns an instance of the active field class. Active field has a hint method, which you can use to add instructions to your form fields. Let's go ahead and let everyone know that our password field has a 6-character minimum. You've probably also noticed that all of the fields are currently text inputs. However, our gender field would really work better as a drop-down, as there are only 2 valid options. Luckily, ActiveField has a drop-down list method, which takes an array of value option pairs as a parameter. Taking another look at our form reveals that our efforts have been rewarded. We can even go a step further and provide a default option. Most of the ActiveField methods used to generate form fields take the options array as a second parameter, which can be used to set CSS class and ID, HTML attributes, and more. The drop-down list takes a parameter called prompt, which allows you to set a default option for your drop-down list. Let's wrap up this video by registering our first monster. We're a little heavy on male monsters at the moment, so let's try to even things out a bit. Press Submit, and you'll see that our monster is saved to our application. A quick check at the database will verify our success. In this video, we learned about custom URL rules, validators, and ActiveForm, and put them all together in order to create a registration page for our application. In the next video, we will learn how to restrict access to controller actions using the Access Control Filter. This is the 4th video of this section, which is called Access Control Filter, the Silver Bullet. In the previous video, we learned how to create a user registration page for our monsters using custom URL rules, model validators, and ActiveForm. Now, we'll learn how to add a little law and order to our application by restricting access to certain pages using the Access Control Filter. The Access Control Filter, or ACF for short, is the broadsword of application security, as its one job is to decide whether to allow or deny access to an entire controller action. The Access Control Filter is implemented in your controller code. It actually adds code that runs before each of your controller actions and decides whether to allow or deny access based on rules that you configure. We previously created a controller for our application with 4 actions, one for each of the standard CRUD operations. It makes sense to allow access to the create and read actions to the world, but it would probably be sensible to restrict access to the edit and delete pages only to logged-in users. So go ahead and open up monstercontroller.php from the controllers folder and add a use statement for the access control class. Then, scroll down to the behaviors method and add an access section. The first setting is class. Every object in Yi has a method called className, which can be used to return the fully qualified class name. So we'll use that to set the access control class. Next, we'll set the only attribute, which takes an array of controller actions to secure. As we've already discussed, we're going to focus on the update and delete action. Adding these 2 lines will now block access to these 2 controller actions for everyone. You'll see that attempts to access either of these pages redirect us to the login page. Moving right along, we'll create a rules item in our configuration, and then create an array of arrays. The innermost arrays provide configuration options for the access rule class. The first attribute to configure is called allow. If you set this to true, it means that you are allowing access to this controller action. Conversely, if you set it to false, the rest of the rule defines who should be denied access to this action. The first rule will be an allow rule, so set it equal to true. Then, create an actions index, and give it an array with 2 values, update and delete. Finally, we use an array with the @ symbol as its only value to set the roles attribute. The @ symbol is a shortcut that ACF interprets as authenticated, or logged in users. Head over to your browser and make sure you're logged out. Open up monstermash.dev/monster and click on any one of the pencil icons, which would normally bring you to the update page. However, as we already saw before, you are now brought to the login page. Let's log in Dracula again. Remember, his username is fangman999 and his password is yummyblood. Click the login button and marvel as you are instantly brought to the update page. Remember to log out, and let's do the same thing with the delete page. Pull up the monster index page again and click one of the garbage can icons. Confirm that you want to delete this item, and you'll be brought to the login page again. Login is Dracula, and you'll be brought to the... Oh wait, there's a problem. We're getting a 405 error, and are told that this is because the delete action can only be invoked by a post request. If we look back at our controller code, we can see that there is actually another filter being applied to this controller, the verb filter. Even without understanding too much about the verb filter, it should be easy to see that it is being used to limit the delete action to post requests. By default, ACF sends you to the login page when it denies access to a page. However, on successful login, Ye sends you to the page you were initially trying to access. But of course, it is doing so using a GET request, not POST. If only we could change the default deny behavior for our delete action. By now, hopefully you have enough faith in Ye to realize that we can do just that. Head to your ACF configuration and add another item, deny callback. We'll define an anonymous function here that takes two parameters, rule and action. The default login redirect behavior is great for the update action, but for the delete action, we can just display an error message. So throw a forbidden HTTP exception with an obvious error message, and that's just what our app will do. Head back to the browser one final time, make sure you're logged out, go to the monster index, click delete, and you'll see our nice error message prominently displayed. Well, we're now at the end of the video. In this video, we have learned how to restrict access to pages in our application using the access control filter. When we return, we'll learn how to create more fine-grained security rules using role-based access control. This is the fifth and last video of this section, implementing role-based access control. In our last video, we learned how to use ACF to control access to individual pages of our application. If ACF is the broadsword of application security, then RBAC is the surgeon's scalpel. We can create user roles and then assign them permissions in order to control access to almost every aspect of our application. We'll look at how to enable the AuthManager, create permissions and roles, and then how to assign roles to our users. Role-based access control is an extremely powerful and flexible tool, which allows you to control what actions your users can perform. The trade-off, however, is that it takes a bit of work to get started. The very first step is to enable the AuthManager component in our application. There are actually two different classes that we can use to store our access rules, PHP Manager and DB Manager. The former stores authorization data in PHP files, where the latter stores it in the database. For simplicity's sake, we're going to use PHP Manager. We'll also need to create an RBAC directory to store our rules. If you've loaded the code samples for this video, we've already done that for you. Next, we'll need to generate the RBAC configuration. Open up monstercontroller.php from the commands directory, and you'll see a few new controller actions that will be used to set up our authorization rules. Console commands have their own configuration file, which is located in config console.php. Add the AuthManager configuration to the components section of this file as well. The first method, action permissions, is used to create two permissions, one called updateMonster and the other called deleteMonster. After creating and describing these permissions, we use the add method to generate configuration files. Switch to the terminal and run the console command monster/permissions. Look at the RBAC directory, and you'll see a new file called items.php, which contains metadata for our two new permissions. Next, we'll create some roles and assign our new permissions to those roles. We're going to set it up so that users in the member role are able to update profiles, while members of the admin role can also delete them. Looking through the action roles method of the monster controller console command, you'll see that we load the permissions objects that we created in the first step and then assign them to local variables. Then we create the member role, add it, and assign it the update monster permission. Next, we create an admin role, add it, assign it the delete permission, and then also assign it all of the permissions that the member role has, which in this case was just the update monster permission. Run this console command, and then inspect items.php for changes. The next thing that we need to do is make sure we assign our monsters to a role. Open up the monster model, and look at the new aftersave method we've created. As one would expect, this method is run after a monster is added or updated. This will now simply assign Dracula to the admin role, and all of the other monsters to the member role. Head back to the terminal and run the load monsters command again so we can assign all of our monsters to a role. Look at the RBAC directory and you'll see that an assignments.php file has been created which maps our user IDs to their new role. Now, let's test out our new delete permission. We can actually integrate our new roles into ACF. We'll head back to controllers monstercontroller.php and look at the ACF rule that we generated in the previous video. Let's split our rule into two. One allow rule for the update action and another for the delete action. In the first browser window, we're logged in as the mummy, who is a member. As you can see, he's unable to delete users. However, our Dracula, our undead admin, is. Don't worry, we'll bring back the Wicked Witch a little bit later. Now, let's work on the update action. But rather than allowing all members to edit each record, it makes sense that members should only be allowed to edit their own profile, while users with the admin role should be able to edit all users. Just for fun, let's focus on showing or hiding the pencil icon, depending on whether a user should or shouldn't be able to edit a particular profile. Open up RBAC profilerule.php from the code samples, and you'll see a class with a name attribute, which is set to own profile, and a public method named execute. In this method, we're checking to see whether the ID of a user matches that of the current user. Now, we need to look at the action rules method in our console command. We create a new instance of our profile rule and add it to the AuthManager. Then, we load our update monster permission and set its rule name attribute to modify own profile. Finally, we update the update monster permission. Now, we need to find the code that generates our list view. It's in views monster index.php. We'll add the following code to apply our new rule to the output of those icons. There's a lot going on here, but most of it's related to the output of the buttons, which is something we'll cover in the next section, so let's ignore it for the moment. Let's focus on this part of the code, which runs the can method of our application user. The can method either takes a role name, in this case admin, as a parameter, or a permission name. So, if a user is an admin, the pencil icon should print next to all of the rows. However, if a user simply has the update monster permission, then it will only print next to their own row. Finally, if the user doesn't have the permission at all, then the icon won't print. So first up, let's see what happened to Dracula. Nothing. He still has a pencil icon on each row. However, Mummy still has a pencil icon only in his row. And, if we log out, we'll see that all of the pencil icons disappear. One last thing to be aware of is that in production, you would also want to check this permission in your controller action, because technically, a user with the update monster permission could still access the update page manually by typing the update URL. That was definitely a lot of information, but hopefully you'll agree that it was well worth the effort. Now, we understand the basics of RBAC, which is the final piece of the user component in our application. We already learned how to configure and create users, make them more secure, and then control their access to controller actions. In the next section, we'll try to spruce up our application by looking at some of the front-end features of Yi. This is section 5 of Learning Yi 2, which is called Adding Some Style. In the previous section, we learned how to create a secure login system for our users. In this section, we'll learn about layouts, which are used to control visual elements that appear on multiple pages. Then, we'll learn how to manage scripts and style sheets using Yi 2 asset bundles. Next, we'll learn how to quickly generate HTML code using the HTMLHelper class. Finally, we'll put together everything we've learned in order to create a profile detail page for our monsters. We'll begin with the first video of this section, all about Yi 2 layouts. We've already learned that the visual aspects of an MVC application are handled by the view component. However, most application views contain elements that are common to multiple views, and it would be very tedious to have to edit these elements in individual view files when making changes. That's where layouts come in. We'll learn all about them in this video. A navigation menu is an element common to multiple pages in a web application, so we'll look at Yi's menu widget. But we may also have views that require an alternate layout, so we'll also learn how to build an additional layout and apply it to selected views. Let's dive right in and take a look at the layout our current application is using. Open up Views, Layouts, Main.php. This is the default layout for the basic application template. At the top, you'll see a series of use statements, as well as a call to the register method of the AppAsset class. We'll discuss asset bundles in further detail in the next video. After that, you'll see an HTML doc type declaration, as well as a standard head section. There are a few calls to methods such as begin page, and begin body. These are the methods that the view component uses to inject front-end assets into our layout. Below the opening wrap div, you'll see the code that generates our site navigation, which we'll look at more closely in just a minute. The part we're going to focus on right now is line 58, where ye outputs the contents of the content variable. When the render method is invoked in a controller action, it loads this layout and then injects the code generated by the corresponding view into this content variable. We can confirm this by removing it momentarily and then reloading our application homepage. This should give you a good sense of what aspects of the page are part of the layout and which parts are generated in the view. Be sure to replace line 58 before moving on. Now that you understand what the layout does, let's look at one of the more interesting components, the navbar. Widgets are components that are used to generate small, reusable UI modules for your application. If it isn't already obvious, ye integrates with Twitter Bootstrap in order to shorten front-end development time. The navbar widget simply outputs HTML code to generate a Twitter Bootstrap navbar. We're not going to be creating an award-winning design for our application in this course, but let's edit a few of the default options just to see if we can learn how to customize its appearance. A logo might be a nice addition to our site layout. We've included one in Web, Images, Logo.png in the code samples. In order to include one, we'll need to get rid of the black bar at the top, which means changing the navbar inverse class to navbar. We'll also get rid of the navbar fixed top class in order to allow it to scroll with the rest of the site. Next, we'll change the brand label setting and replace the default text with an image tag. Next, let's change our links in order to accurately reflect the main pages of our application. You can configure your menu using the Items attribute of the nav widget. Let's change the home page link to a members link and link it to our monster listing page. Simple enough, right? Skipping ahead, if you look at the code that generates the login and logout links, you'll notice that it uses a ternary operator in order to generate a login link if the user hasn't logged in yet, and a logout link if they have. We could do this with our register and profile pages, but instead, let's learn an alternate syntax. Create two more configuration arrays, but this time give them an extra index, visible. This takes a Boolean value, which determines whether the menu item is displayed or not. In the case of our register link, we only want it to appear if the user hasn't logged in yet. Conversely, we only want our profile link to appear for registered users. Also notice that the URL setting for the profile link, we provide a second parameter to the action update in the monster controller so that the application knows to load the currently active user's profile. Head over to our browser, and you'll see that our register links appear as expected. Login is Dracula, and you'll see that the register link will be replaced with the profile link. Finally, wouldn't it be nice if we could apply a different layout to some of our views? For instance, our application homepage probably doesn't need a menu or a footer. So let's duplicate our main layout file and call it simple.php. Delete all of the nav and navbar code, the breadcrumbs, and the site footer. Next, switch over to the index view, which is located in Views Site. Just to be thorough, we'll change the title of this page to Monster Mash. I'm going to add a use statement for the URL helper, which will help me generate a link in the next step. Change the heading and lead text to something a little more appropriate, as well as the button text. Finally, we'll use the URL helper in order to generate a link to our monster listing page. The last step is to tell our view to use the simple layout. This is achieved by opening up the site controller and modifying the action index method. Set the layout attribute of the controller equal to simple. Now, open the home page of your application, and you'll see that ye has applied our simpler layout. But click on the button, and you'll see that the interior pages are still using our main layout. Now that you understand what layouts are and how to use them, you should feel comfortable customizing elements that appear in multiple views in your application. In the next video, we'll learn how to manage front-end assets, such as JavaScript and CSS, using asset bundles. This is the second video of Section 5, which is called Managing JavaScript and CSS. In our last video, we learned how to work with layouts, which control UI elements that are common to multiple views. We learned early on in our course that Yi2 uses the popular PHP package manager Composer to handle our application's dependencies. Front-end application developers typically use their own package manager. Bower is currently a popular front-end package manager. Before we installed the basic application template, we installed the Composer Bower Asset plugin, which allows us to install packages that are typically handled by Bower using Composer. In this video, we'll use the Composer Bower Asset plugin to install a new package and then learn how to use the Yi2 AssetManager component to include our new library in our application. Before we learn how to install a new package, let's take a look at the asset bundle that ships with Yi's basic application template in order to try to understand how it works. If you remember from our last video, our main layout included a call to the register method of the AppAsset class. The AppAsset class extends from the Yi2 Asset Bundle class, and the register method tells the asset bundle to attach itself to the current view component. Open up Assets appasset.php and look at what's happening. You'll see that we have one CSS file defined in the CSS property of the class. If you switch to the app and view source, you'll see that this line is responsible for adding site.css to a queue of scripts and stylesheets to output in the head method of the view component. You'll also see that there are no scripts defined directly in the AppAsset class. However, we do have two classes referenced in the Depends attribute. The Depends attribute simply points to other asset bundle classes, which have their own sets of scripts and stylesheets. We'll demonstrate the usefulness of this Depends attribute shortly. For now, you can simply see that the application uses the Yi and Bootstrap assets, which we've already mentioned in previous videos. A quick look at these two assets, and then at the source, we'll clarify how Yi knows what script and link tags to generate. Let's switch to a terminal window and install a new Bower package. The jQuery Lightbox plugin, which is used to generate modal dialogues, could prove useful for our dating application. Simply switch to the application root and type composer require, and then the package name, which in this case is hiq-dev/e2-asset-lightbox2. Wait for Composer to finish working its magic, and then switch back to your code editor. Browse to Vendor, hiq-dev, lightbox2, and you'll see that Composer has magically installed the Lightbox2 plugin for us. Now, in order to load this into our main layout, we could add a call to the register method of the Lightbox asset in our main layout, but it's easier to simply return to our AppAsset class and add the Lightbox asset class as a dependency. That means when the app asset is registered, it will automatically register our Lightbox asset as well as any of its dependencies. Open up our browser and view the source. We'll see a link tag, which loads lightbox.css in the head section, and a script tag, which loads lightbox.min.js right after the closing body tag. In this video, we learned how to use asset bundles to manage the front-end assets for our application. In the next video, we will take a look at the HTMLHelper, which helps generate HTML code using PHP methods. This is the third video of Section 5, and this video is called Introducing the Yi2 HTMLHelper. In the previous video, we learned how we could use asset bundles to manage JavaScript and CSS. One of the main tasks of a server-side framework is to generate HTML markup to display data to the users. This is frequently achieved by writing HTML and then escaping in and out of PHP using opening and closing tags to output dynamic data. The problem is that this can quickly lead to unreadable and unmanageable code. So Yi provides us with an HTMLHelper class whose sole responsibility is to quickly and efficiently generate markup. If you've been developing applications for the web for any period of time, you've most likely heard the expression sanitize input, escape output. The HTMLHelper can help us with the second part of that equation, escaping output. Let's take a look at why we might want to do this in the first place. We've logged in as the mummy, and we're editing his profile. In the name field, Let's actually enter a JavaScript tag as well as some benign code. Save the changes, and you'll see that the code we entered appears as text in the name box on the Mummy's view page. The only reason this happens is because the widget that generates this view page uses the HTMLHelper's encode method on this output. View the source on this page, and you'll see that the HTMLHelper has converted all of the opening and closing carets to HTML entities, which causes the browser to output our script as text rather than interpreting it as a script and executing it. However, if I open up views, monster, view.php, and make a small change to the name column, I can disable the encode method. Now, if I reload the page, my JavaScript is actually executed and an alert dialog is generated. Imagine if someone replaced my friendly JavaScript with something more malicious. Even Dracula should be frightened by that thought. By the way, these kinds of attacks are called cross-site scripting, or XSS for short. Another way that the HTMLHelper can assist you is by generating HTML tags, complete with attributes and content. Let's try an example that will demonstrate why you might want to use this feature. Open up Views, Site, index.php, and look at the HTML that generates the Find Your Match call to action button. You'll see that we already escaped once into PHP in order to generate our href destination using the URL helper. Now, let's imagine that there were also a few other classes that we might need to apply to this button depending on a set of circumstances. We'd have to add another series of inline if-then statements, which could get messy quickly. Instead, let's use the A method of the HTMLHelper, which is used to generate a link tag. The first parameter is the link text, which in this case is find your match. The second parameter is the URL, which is /monster, and the final parameter is an array of options. Each array key is the attribute name, and the value is the value of that attribute. We'll use it to set the class, which is currently a set of Bootstrap classes. These classes make the link look like a button. But what if we wanted to vary the color of this button? For a moment, let's create an arbitrary circumstance. At the top of our view file, we'll write a small script, which first assigns a button class variable a series of CSS classes, which set the size and shape of our button. Then, we'll add a ternary operator that varies the class based on whether the current time in seconds is even or odd. And that will vary whether the button is green or orange. Finally, replace the class assignment in our link generator, and then reload the page several times. We'll see that the class changes depending on the script execution time. If you have ever developed a PHP application without a framework, then you know that one of the most tedious aspects can be working with forms. You need to generate fields, validate data, display errors, and possibly repopulate fields with previously submitted data. We already looked at how ActiveForm is used to generate the forms on our create and update pages, but what you may not realize is that the ActiveForm object simply uses HTMLHelper's methods to generate each form input. We're going to revisit our About page now, which we've repurposed in a few of our earlier videos in order to demonstrate various features of Yi. In fact, when we created a form on this page during the automated testing section, we used ActiveForm to generate all of our form code. Let's improve one of our fields in order to demonstrate a slightly advanced usage of the HTMLHelper form field methods. If you remember, we had a text input where our users could input a monster's name, which would then be output on form submit. What if, instead of a text input, we wanted to generate a list of radio buttons for each monster stored in our database? We can use the radio list method. The first parameter for this method is the input name, which remains unchanged, monster name. The second is the currently selected radio button. Let's say that because monsters can be a little bit vain, that if one of them is logged in, that their name will be selected by default. Otherwise, we won't select one by default. Because we're trying to keep our HTML as clean as possible, we'll define a variable called selectedMonster in the opening PHP block, and then pass it to the radio list method below. The third parameter is a list of options which will be used to generate both the text and values of each radio button. Yi provides another helper object called the array helper, which can be used to build a map, or an array of key-value pairs, which in turn can be used to generate select options for dropdowns, checkbox lists, and radio button lists. The method is appropriately named map. Its first parameter is an array or an array of objects. In this case, let's provide it an array of all the monsters in the system using a finder. The second is the attribute to be used as the radio button's value. The third is the attribute which will be used to generate the options label or text. We'll use the name property for both here. Now, remember to add use statements for both the array helper and monster classes at the top of the page. Now, reload the About page, and we'll see that we have a group of radio buttons with dynamic options and a default selection, and it was all done with just a single line of code. It should now be clear how the HTML helper can help you keep your views more organized and even allow you to write less code. We'll conclude this section in our next and final video by putting together everything we've learned to create a profile detail page for our romantic hopefuls. In our final video of this section, which is entitled Monster Profiling: The Scary Details, we will take some of the skills we learned in previous videos in order to upgrade our profile page. We will add a URL rule to make our page easier to link to. Then, we'll add a profile photo and incorporate the Lightbox plugin that we installed in video 2 of this section. Next, we'll do a little tidying up in the user information section. Finally, we'll make sure that the edit and delete buttons don't appear when viewing someone else's profile. Let's jump right in and add that custom profile URL rule. Open up the main application configuration file and scroll down to the URL Manager component configuration. We'll add a rule much like the one we did for the register page. However, this time we need to keep in mind that the view action of the monster controller, which we'll use as a basis for our profile page, takes an ID parameter to determine which model it should load. In order to preserve this functionality, we need to use a regular expression to tell the URL Manager component the name of our parameter, as well as what format to expect. Start with the name of the parameter, followed by a colon, and then add a regular expression to tell Yi to expect one or more numerical characters. Save the file, and open the monster listing page. If you look in the bottom corner of our browser, you'll see that the URL has already been updated when you roll the mouse over the eyeball icon. Click on the eyeball icon, and you'll see that our URL format has changed. Next up, we'll go ahead and add a profile photo. For now, we're just going to create a photos directory in the web root and copy our photos directly there. We went ahead and added a photo for Frankenstein, as well as a default image for the rest of our monsters who haven't supplied us with a profile photo yet. Open up the monster model class and create a getPhotoInfo method. This method will return an array with the photo source location and alt tag text. If a photo exists with the monster's name, its file name will be provided as the URL value of our return array. Otherwise, a default image will be loaded. Don't forget to add a use statement for the URL helper. Now, we'll open up our view and output the photo. But before we do, we'll update the H1 a little bit just to make it look like it's a real dating site. Next, create a photoInfo variable and assign it to the photoInfo attribute of the monster model. Remember, Yi will use a magic getter method to return the contents of the getPhotoInfo method. Now, we'll create a second variable called photo and create an image tag using the HTML helper. We'll explain why in a minute. Create a figure tag under the main heading. Use the HTML helper's A method to generate a link tag. The content of the tag will be our photo variable from the previous step. We could have simply made the call to the image method here, but for readability we put it in the top in the opening PHP block. The second parameter is the URL, which was provided by our photoInfo variable. The third parameter is an array of additional attributes for our link tag. We'll add two, data lightbox and data title. These two attributes will be used to activate the lightbox with a larger version of our profile photo when the link is clicked. Just for clarity's sake, we'll add a little fig caption that lets everyone know that they can click the photo to view a larger image. To finish it off, we'll open up the site.css file to restrict the max width of the thumbnail image, as well as create a little bit of space between the image and fig caption. Save everything and click on the view icon next to Frankenstein. You'll see his spiffy new photo show up. Clicking on it opens a lightbox with a larger version. If we go back and look at Dracula's page, we'll actually see that the default avatar shows up, because there isn't a file named dracula.jpg in the photos directory. Our next step is to clean up the profile information section. We'll move the buttons below the profile table for a moment. Let's add a secondary heading so that everyone is clear that this is the profile information section of the page. Next, remove ID, username, password, and auth key columns, as our monsters won't find these very helpful in their search for true love. It's also hard not to notice that the gender information is a little sparse. Let's create another virtual attribute in our monster model to output something a bit more informative. Simply add a public method called getProfileGender and return bachelor if gender equals M and bachelorette if it equals F. Switch back to the list view and switch the gender column to profile gender. Reload the page and you'll see that our profile information is now in better shape. The last thing we'll do in this section is clean up the update and delete buttons a bit. First, update the text on them just a hair, just to make them look like they belong on a real dating site. Next, these buttons should really only appear if the monster viewing this profile actually owns it. Since we already coded the permission to check if a monster owns a profile, it's simply a matter of adding a call to the can method of the application user object. If you remember from the video on RBAC, the permission name is updateMonster, and we have to pass it an array with an index of user and a value of the user object of the profile we're currently viewing. That object is contained in the model variable. Because we're not currently logged in, go ahead and view one of the profile pages, and you'll see that the buttons are gone. Now, log in as Frankenstein, view his profile page, and you'll see that the buttons magically appear. We've learned a lot so far throughout this course, and we were able to apply a lot of our newfound knowledge in creating a better profile page for our monsters. We started with the default view action generated by Guy, changed the URL, added a profile photo complete with Lightbox, spruced up the profile information section, and made the profile edit button show up where appropriate. Earlier in the section, we learned how to edit common UI elements through our application using layouts. We also learned how to install and manage front-end packages with the AssetManager component. Afterwards, we learned how to work with Yi's HTMLHelper class. Coming up, we'll learn how to create a better search function for our monsters in order to allow them to find the perfect match. This section is called Finding Love. In this section, we will learn all about the ActiveQuery component in Yi 2, which helps us easily generate more complex SQL queries in order to search through our application data quickly. We'll also attempt to spruce up the search UI a bit using a Twitter Bootstrap-based widget. Next, we'll learn how to sort and paginate our search results using the List View widget. Finally, we'll learn how to create and use alternate themes for our application. Let's jump right into the first video of this section, Finding the Right Ghoulmate using ActiveQuery. In this video, we'll learn how to use the ActiveQuery component to search through our application's data. We'll learn how to perform several different types of searches, including partial string matches, exact string matches, integer range searches, as well as searching for data in related tables. Without further delay, let's get started. There's a little bit of extra work that we need to get prepared for this video. Check out video 6.1 in the code samples, and then run section6.sql, which is located in the DB directory, on your database using your favorite MySQL management tool. Now, log into your Vagrant server, switch to your project application root, and rerun the monster load monsters command using the Yi executable. We've added an additional table, skin, as well as a column in the monster table called skin ID, which links each monster record to a value in that skin table. You'll see why we did that in just a minute. For now, let's work on our list view for a minute, which is where our search fields are going to go. Before we do that though, let's quickly remove the Create Monster button from this page, because we're now using our Register page to create new monsters. You may already notice that there is some code in this view that references another partial view called _search on this page, but that it's commented out. Go ahead and uncomment it, and reload the listing page. You'll see that our new form appears above the list of monsters. The code that controls this form is located in views, monster, _search.php. So let's go ahead and open it up. The first thing that we'll do is get rid of the ID, password, and auth key lines, because it doesn't really make any sense to search those fields. Let's go ahead and type M in the gender box, and then click the search button, and you'll see that only our male monsters show up on our list. But how does that work? Open up controllers, monstercontroller.php, and look at the action index method. You'll see that the controller loads an instance of our monster search model, which we generated with Guy earlier, and then provides the search parameters to its search method. So the next logical step is to open up the monster search model and see how the search method works. In short, it returns an active data provider object, which takes the return value of monster find as a parameter. Find simply returns an instance of ActiveQuery, and that's what this video will focus on. You can see that after the search parameters are loaded and the model is validated, that the ActiveQuery object uses method chaining to add a series of conditions to our query. All calls use the andFilterWhere method to add where statements to our SQL query. The first syntax you see simply has key value pairs. This will generate an equals condition. You'll see that age is searched for this way. So for instance, if we switch back to our browser and we search for 99 in age, we get no results. However, if we search for 999, Dracula is returned. The second syntax takes an extra parameter at the beginning of the method, and that parameter specifies something called an operand. For instance, you can see that name uses the like operand. This means ye will append a like query to your SQL. So go ahead and type dr in the full name field, and you'll find that Dracula is again returned. Returning to our monster search model, we can see that it probably isn't helpful to search for an age using an exact match, but gender might be a good candidate for this field. We'll also get rid of ID because we've already removed that from our search form. While we're at it, let's go ahead and copy the gender dropdown from our monster creation form into the search form so that only valid values can be entered. It doesn't make much sense to search by exact age, but rather for a range of ages. So first, let's change the age input to begin age. Then we'll duplicate this line and change the second one to end age. Next, we need to move over to the monster search model and add these as public attributes, because otherwise ye won't allow us to set them in the controller. Because they should be an integer, we'll also go ahead and add them to the corresponding rule. Finally, we need to head down to the search method and add a few andFilterWhere lines. The operand for begin age will be greater than or equals, and the operand for end age will be less than or equals. Run a couple of searches, and you'll see that we're on the right track. The final type of search that we'll do is for related values. All of that SQL we ran at the beginning of the video created a skin table, which has a few options for skin tone. Let's face it, monsters focus on appearance just like the rest of us. When we reloaded the data in our monster table, we also added some values linking each monster record to a corresponding skin tone using a foreign key. The skin model is linked to the monster model using the active record relations feature. Let's use what we just learned in the last section to generate a checkbox list of all of the different options for skin tone. Head to your search form partial view and add a use statement for the array helper and skin classes. We'll use the map method again to create a map of all of the different skin tones in the skin table. Next, let's use the checkbox list method of the active field object to generate our list and feed it the map that we just created as its only parameter. Finally, we have to add another validation rule and another andFilterWhere call to the search method of monster search. This time, the operand is in. Switch back to the browser and search for monsters with green skin. You'll see that Frankenstein and the Wicked Witch are returned. Add pale to your search options, and Dracula will join the party. Now you know how to use ActiveQuery to create complex SQL statements with a minimal amount of effort. In the next video, we'll try to spruce up our search UI a little bit and add the TypeAhead widget. We're now in video 2 of section 6, which is called Enhancing the Search UI. In our previous video, we learned how to create complex SQL statements in order to allow our monsters to come one step closer to finding true love. Now, we're going to learn how to jazz up our search UI. We'll use the TypeAhead widget in order to provide pertinent suggestions when searching for a user by name. First, we'll learn how to install the widget using Composer. Then, we'll learn how to output widget code using the ActiveField class. Finally, we'll learn how to configure advanced options to spice up our search field. Let's start off by installing the TypeAhead widget, which is simply a package that wraps the HTML and JavaScript for the Twitter TypeAhead.js plugin and allows us to configure and generate that code using PHP methods. Rather than using the require command of Composer, let's explore an alternate way of installing packages. Open up composer.json from the root of your application and add the name of your package to the require section. The package name is cardic-v/e2-widget-typeahead. We'll let Composer decide which version to install. Save the file, and then type Composer update on the command line. Now that we have the package installed, we're going to replace the current name text field on our search form with the new widget. Add a use statement in the opening PHP block of the form. The package we installed actually includes two classes, TypeAhead and TypeAhead Basic. We'll use the latter. We've seen other widgets throughout our course, and usually they are invoked by calling the widget method directly from the parent class. However, because this widget will be tied to an active record attribute, we'll use the widget method of the active field class. The first parameter is the name of the class of your widget, so we'll let the class name method of the TypeAhead Basic class do the heavy lifting for us. The second parameter is an array of options, which we'll use to configure our widget. For now, we need to worry about a single option, which is called data. The data setting is an array of suggestions that the TypeAhead will use to provide options once our users start typing in the name field. Because we're searching for monster names, we'll naturally want to provide a list of all of the names in our database as our suggestions. Once again, we're going to call on the array helper to help us quickly build an array of all of the usernames in our system. We've already included the array helper in the previous video, but we'll need to add a use statement for the monster class in order to create our list. In the past, we've used map method of the array helper class in order to generate arrays made up of index value pairs. This time, though, the data parameter only takes a one-dimensional array, so we're going to use the getColumn method instead. The first parameter is an array or an array of objects. We'll use the findAll method of the monster class in order to retrieve all of our monsters. The second parameter is the name of the attribute to populate our array with. In this case, it's obviously name. Now, go back down to your widget call and add your monster name array to the data option. Save the file and go back to the monster list page. Start typing in the full name search box, and you'll see that we start to see suggestions that match the characters we type. Not bad, but wouldn't it be neat if we could actually let our users know that this functionality existed? Add another option parameter called options with the key placeholder and the value of begin typing to see suggestions. Switch back to the form, and you'll see that this message shows up in the box until you start typing. Next, add another option called plugin options. Set it equal to an array with an index of highlight and a value of true. Save the file again and switch back to the search form. When you start typing this time, you'll see the letters that match your search query are bolded in order to stand out. The bold highlight is nice, but because monsters aren't known as the most observant demographic, let's make the highlight standing out a bit more. Open up site.css and add a rule for the tt-highlight class. Set the background color property equal to yellow. Now, you'll see that your search term is highlighted in a much more obvious way. Hopefully even Frankenstein won't have to squint to see that. We learned to install and use the TypeAhead widget in this video in order to make our search form a bit more user-friendly. Up next, we'll learn how to make our monster list page resemble a real dating site, as well as learn how to sort and paginate our results. Hello, and welcome to Displaying and Sorting Results, which is the third video of Section 6 of Learning E2. In our last video, we improved our search UI by installing the TypeAhead widget. In this video, we'll focus on the appearance of our search results. At the moment, we're using the grid view widget to display monsters on our listing page. However, the Grid View widget is better suited for an admin panel of a site, as it contains little styling and includes buttons to perform CRUD actions on models. Therefore, we'll learn how to use the List View widget instead, which allows us to customize the appearance of each monster model. After we get the List View widget set up, we'll then learn how to use it to sort and paginate our results. Once again, we need to do a little bit of preliminary work before we start this video. Load the code samples for this video, and then run the load monsters console command. We've added a few more members to our dating site in order to help assist with the next steps. The first step is to open views, monster, index.php. We'll replace the use statement at the top and instead include the list view widget. Now, remove the grid view code entirely and call the widget method of the list view class. This widget also has a data provider attribute. We'll provide it with the output of the monster search model's search method, which is an instance of the active data provider class. The list view will loop through each model in the data provider and inject it into either a partial view or an anonymous function that controls how each item appears. We need to configure the item view attribute to point to our new partial view. We've already created a partial view in the samples and named it _monster.php. You can feel free to look at this partial view on your own. There's nothing in there that you don't already know how to do. By default, each partial view will be wrapped in a div tag. In order to make styling those divs a little easier, we'll use the item options attribute to add a unique class to each div. We've also added some styles to our site.css file, but we won't go into detail on those right now. Switch over to the browser and reload our monster page. You'll see that our monster list looks quite different. It displays each monster's profile picture, some information about them, and then a link to their full profile. Again, all of the code used to generate each of these monster items is located in the _monster.php partial view. Not bad, right? Now, let's look at how we can set up a little bit of advanced functionality on our list view. First, let's add the ability to sort our monsters by a few of their attributes. Fortunately, 90% of the work is already done by Yi. We just have to set a few configuration options in order to complete the job. First, we have to enable the sort links on top of the list view. The list view widget has a layout attribute, which controls the order in which its parts appear. The sort links are left out of this layout by default, so we simply need to add them back in and take care to make sure we don't leave out any of the other existing parts, which include the summary, items, and pager. Now, if we head back to the page, we'll see that our sort links are added back in, but we probably have more than we need. In order to control which attributes are sortable, simply open up models monstersearch.php and add a sort attribute to our active data provider. It has an attributes attribute, which can be used to control our list of sortable attributes. We could probably benefit from the ability to sort by full name, age, gender, and skin tone. Head back to the browser again, and you'll see that our sort links have been updated. Click on one to see how well it works. Clicking a link a second time will actually sort that attribute in reverse order. One of the main reasons that we added new monsters at the beginning of this video is that it is often helpful to break long lists of items into separate pages. So having a longer list of monsters will help make the results of our data pagination more obvious. Getting this set up is remarkably easy because your results are already being paginated. However, the results per page are set to infinite by default, so that all of your models will always be displayed on one page. In order to change that, you just have to go back to the monster search model one more time and configure the pagination attribute of the active data provider. It has a page size setting. For demonstration purposes, let's set that equal to 3. You'll see now that our summary reflects that it is only showing the first 3 results. We'll also see that there are only 3 monsters on the page. Finally, we also see that there are 3 pages of results, and a set of links to the other pages at the bottom of the list view. Clicking on additional pages shows you additional models. One of the best part of all of this becomes apparent when you click on one of the sort links. You'll see that Yi keeps track of what page you're on and what attributes you're sorting on, so that you always see the data you expect to see in the order that you expect to see it in. And that's it. You now know how to use the List View widget to display your model data in a listing view. We'll wrap up this section in the next video by learning how to create and use alternate themes in our application. Welcome back to the final video of Section 6, Adding New Themes. In the last video, we learned how to use the List View widget to display a list of models. In this video, we will look at how we can create alternate themes for our application. We've already discussed that Yi implements the model view controller pattern. Themes are simply alternate views that allow you to change the way your application looks without having to change any of the code in your models or controllers. We'll show you how to create a new theme and then apply it universally. Then, we'll look at one way to apply your new theme to a certain subsection of your user base. Because we are simply creating new views for our application, we need to create a themes directory in our application root. Inside of that directory, we will create a new subdirectory, which is named after our new theme. We're going to make an alternate list view for our female users, so let's call the theme Feminine. There are two ways to set up themes in Yi. Using the first method, you would simply copy the entire views directory into your new theme directory, and configure the view component to look for all its files in that theme directory. This is useful if you are making major changes to all of your views in a theme. The second way is to only create new files in the themes directory that correspond directly to files in the view directory that you want to override. Yi will first look for a view in this new theme directory, and if it finds the file, it will load it. If it doesn't find the view file in the themes directory, it will go back to the original views directory. We're going to take the second approach in this video. Create a monster subdirectory, and then paste views monster_monster.php to that new folder. Let's imagine that we've gotten word that our female monsters prefer to see details about their potential matches before they look at a photo. All we need to do is cut the figure tag and its contents and paste it underneath the profile details. While we're at it, let's also make a change to the CSS. There are several ways to do this, but because we're only making minor changes, let's create a new file in the CSS directory called feminine.css. We'll add an import statement at the top in order to use the main CSS file as a starting point. Then, we'll add a simple rule to the navbar class and make the background color pink. This is admittedly not the most subtle choice, but it will help illustrate the technical concept nicely. Now, we need to apply our new theme to the site. Open up web.php in the config directory and add another section to the view component configuration. We're going to configure the path map attribute of the view component. The index will be the original path to our application views, which is app views. And we're going to tell it to look for our new views in app themes feminine. When we pull up our monster listing page, we should see that the photos now appear underneath the profile information. However, if we click on one of the profile detail links, we'll see that our original detail view is still intact. But where is our pink navbar? In order to get Yi to recognize our new CSS file, we'll have to reconfigure our app asset, which determines what CSS style sheets are loaded. But rather than editing the file directly, which makes the change permanent, let's configure it through the web.php file. We'll add a configuration for the AssetManager component, and then configure its bundles property. Now, we put in app, assets, app asset, and we set its CSS property equal to our new CSS file. Now head back to the browser, and you'll see that our lovely new pink navbar appears. But there's an obvious problem with what we've done so far. Our feminine theme is appearing for everyone, regardless of their gender. In order to fix that, let's start off by commenting out all of the new code that we just added. Next, we need to find a way to apply this configuration only when a female user is logged in. It turns out that there are many ways to do this in Yi, so we'll just pick one. Open up monstercontroller.php and create a beforeAction method with a single parameter named action. This method will be run before each controller action. Before we write any code, we need to make sure the controller's parent beforeAction method returns true, and if it doesn't, return false in order to halt the script. Then, we'll check to see if our application user is logged in, and whether they're a female. If they are, We'll essentially apply the same configuration options to the View and AssetManager components that we did in web.php, but this time by setting the object property values manually. Set the theme attribute of the View component equal to a new theme object and pass in your path map configuration from web.php. Then, in order to load our new CSS, you need to access the app asset object by using the AssetManager's getBundle method. Pass the fully qualified class name in as a parameter. Then, set the CSS attribute of your app asset bundle equal to your new CSS file. At the end of your before action method, make certain to return true so that your controller's actions can continue to execute. Finally, add a use statement for the theme component. Head back to your browser and load the monster list page again. You'll see that the photos are on the top and that the navbar background is white. Login as Medusa, however, and you'll see that our new theme has been activated. Now you know how to create alternate view files for your application using themes, and how to apply them both universally and dynamically. Prior to this, you learned how to create a search interface for your application using ActiveQuery. You also learned how to improve the UI for your search interface using the TypeAhead widget. Finally, you learned how to use the List View widget to improve the appearance of our monster listing page. At this point, we have a very basic but fully functional dating website for our monsters. In the next and last section of this course, we'll learn about a few of the advanced features of Yi2, which can help you take your applications to the next level. This final section is entitled Beyond the Basics. In this section, we'll learn how to send nicely formatted HTML emails using SwiftMailer. We'll also learn how to upload and modify images. Next, we'll learn a better way of managing database changes. Finally, we'll wrap up by learning how to translate our application into multiple languages. In this first video, sending emails using SwiftMailer, we'll learn how to configure our application to send emails. You can create your own mailer component to work with emails, but it's unnecessary because Yi is already tightly integrated with the popular SwiftMail library. We'll learn to configure the mailer component, compose messages, and then send them using this built-in library. The first step to sending emails in Yi is to configure the component. Open up web.php and scroll to the mailer configuration. You'll see that a variable called useFileTransport is set to true. A transport in SwiftMailer is simply a class that defines how a message will be sent. Common transports are SMTP, SendMail, and the file transport. We'll ultimately use the file transport in this video, which simply means that the email is written to a text file when the send method is invoked. But let's quickly show you how you would use this to set up the SMTP transport, because this is probably what you would do in a production app. First, you would set useFileTransport equal to false. Now, create another attribute named transport and pass it an array of values. The first key is class, and its value is the fully qualified class name of the SwiftMail SMTP transport. The remaining key value pairs are all common settings used to configure an SMTP client, such as host, username, and password. We'll add them here, and then comment them out so that you have them for reference when you look back at the code samples. Finally, set useFileTransport back to true again. We're going to be sending an HTML email from our application each time a new user signs up. Generating content for an HTML email in Yi is the same as generating a page in your application. Emails have their own layout, and a basic layout is provided for you in Mail, Layouts, html.php. If you open that file up, you'll see it looks very similar to the main application layout, but without a lot of the links to external resources or widgets. While we're in here, let's take a moment to add our logo to the top of our application-generated emails. First, we have to generate a link to our logo to use as the source attribute of our image tag. We'll use the URLHelper's to method as usual to do this. However, this time, we'll pass a second Boolean parameter with the value of true. This will cause the URL manager to generate an absolute link, because the file will always be hosted on our server rather than embedded as an inline attachment. Next, simply use the HTMLHelper to generate the image tag. Next, we'll create the body of our message. Create a file in the mail directory called register.php. This is going to be a very basic email. We'll start with a doc block and add a var definition for our model variable. We'll eventually pass the newly created monster into this email to include a bit of dynamic data, and this just helps our IDE with code completion. Next, we'll add a quick heading and a thank you paragraph, which will include the monster's name and then a reminder of their username for their records. Now, in order to tie this all together and send the email, go ahead and open up our monster controller and head to the ActionCreate method, which you probably remember is the method that generates and processes our registration page. We'll head down to the portion of the method that executes when a monster is successfully created, and right before we redirect them to their profile page, we'll send a confirmation email. Make a call to the compose method of the email or application component. The first parameter is the name of the email view, which is register, and the second parameter is where we'll pass our newly created model into that view. It works the same as the render method in our controller actions. Next, we'll use method chaining to set some of the metadata for our email, such as who it's from, who it's going to, and so on. We don't have email addresses for our monsters, so we'll just send it to test@test.com for now, but typically you would store this information with your user models and then pass it to the set_to method. When we finish setting up our email, we make a final call to the send method, and voila, we're ready to try out our new feature. Apparently, Bigfoot has gotten very lonely all by himself in the woods over the years, so he wants to try his hand at romance. We'll head to the registration page and set him up with an account. The details aren't very important. Click the Create button, and you'll see that you're brought to the profile page as expected. Now, let's confirm that our email was sent. Click on the Debug toolbar, and using the Last 10 Requests drop-down, select the second call to the Register action. Click on it, and then click on the Mail tab on the left. You can see that our email was successfully sent. It was written to a file, and that all of our dynamic data was injected properly into it. At the bottom of the debug data, you'll also see a link to download the actual message in email format. We'll do that quickly, and then open it with Apple Mail in order to verify that our email looks like it should. Although this was a basic example, you should now feel comfortable managing the email component of your application. In the next video, we will learn how to upload and work with images. This is video number 2 of section 7, which is called Working with Images. In our last video, we learned how to send emails with SwiftMailer and Yee. Now, we'll learn how to let our monsters upload their own profile photos, and learn how to use the Imagine extension to manipulate those images before saving them to the server. When we added a profile photo to our application, you probably noticed that we had to manually copy images to the Photos directory, which obviously wouldn't be very practical in a production application. We'll start off by learning how to upload and validate files using Yee 2. Then, we'll go a step further and learn how to install and use the Imagine extension in order to manipulate our images before saving them. Let's dive right in and open up our monster form. We need to make 2 quick changes to allow an image upload on our Create and Update pages. First, we need to change the encoding type of our form in order to process files. We can do that by passing an options array to the begin form method of the ActiveForm widget. The other thing we need to do is add a file control. We'll call the attribute ImageFile, and the method to generate a file input is appropriately named FileInput. Next, let's move over to our monster model. We need to add a public attribute called ImageFile in order to store the uploaded file for processing. We also need to add a new validation rule for this new attribute. We're going to use the file validator, and we're going to set skipOnEmpty equal to true so that the validation doesn't run if a file isn't uploaded. Finally, we need to tell the validator what a list of allowable extensions for our image will be. Next, we'll create an upload method. We'll save the body of the method for a minute, but we'll finish off this step by adding a call to it in our before save method. so that it runs each time we write a monster to the database. Now it's time to edit our controller. File uploads are handled using the uploaded file class. We'll start out as usual by adding a use statement to the top. Now we'll go to the action create method and assign model image file the return value of uploaded file getInstance, which takes the model itself and the name of the attribute as parameters. Please note that this method will return null if no file is uploaded. We also need to call the same code in the update method, but we need to alter it a little bit in order to make sure that we first load the form data, then set the image file attribute, and then finally save our model. The final step is to head back and fill in the body of our monster model's upload method. First, we'll make sure nothing happens if no file has been uploaded. If one is, we have to set the path and file name. We stole this code from our getPhotoInfo method. Clearly this could use some refactoring, but as it won't help us directly with our file upload, we'll skip it for now. Finally, call the SaveAs method of the uploaded file class and provide it with our path and file name. As always, let's head to the browser. Go ahead and log in as Bigfoot. Use whatever username and password you entered when we created his account in the last video. If you can't remember it, you can always delete him in your database and complete these same steps from the register page. We've placed a sample image in the Photos directory. When you get the image file input control, select Bigfoot sample photo.jpg, and now press the Update or Create button, and you should see that the new image has been uploaded. If you open up Web, Images, Photos, you'll also see that the file name was renamed as per our instructions. That's great if you want to display your images exactly as your users upload them, but what happens when you want to perform some processing before saving the image to disk? That's where the Imagine extension comes in. It's really just a port of a very popular image processing library with the same name for Yi. It isn't included by default, so we'll use Composer to install it. Connect to your Vagrant box, switch to your application root, and run composer require prefer dist yisoft /yi2-imagine. Next, open your model back up. Add a use statement for the image class of the Imagine library. Imagine can be used to create thumbnails, rotate images, crop them, and much more. In order to make its effects easy to see, we'll add a 20-pixel green frame to our image. Head to the Upload method and comment out the line that saves the file. Instead, call the Frame method of the image class. The first parameter is the location of the file to manipulate. We can get this using the temp name attribute of our uploaded file class. The other parameters are the radius, hex color, and alpha value of the border. Now, chain a call to the Save method, and once again provide the path and file name. Additionally, we can set the JPEG quality through a second parameter. We'll use 90. Head back to the browser and re-upload our sample photo. You'll now see that it has a 20-pixel green border, just as we expected. Pretty neat, huh? So now you know how to upload images as well as perform processing on them with the Imagine library. Up until now, we've managed our database changes with SQL files. So in our next video, we'll learn how to use migrations in order to keep better track of those changes. This video is called Tracking Database Changes Using Migrations. This is the third video of Section 7. In our last video, we learned how to upload and manipulate images. Now, we'll learn how to manage database changes in our application using migrations. Many developers use version control software in order to track changes to their application code. However, very few track changes to their database schema and data throughout the development lifecycle. That's where migrations come in. We'll learn how to create a migration template using one of Yi's command line operations. Then, we'll learn how to apply some database changes using that template. Finally, we'll learn how to revert our migration and undo all of the work we just did. The Yi migration class is used to add and remove database tables, columns, indexes, and data. Furthermore, it stores a history of which migrations were applied and when they were applied. This history also makes it very easy to undo changes when something goes wrong. You'll remember that we created a small related table called skin in order to track the skin tone of our monsters. We saved the SQL code in db section6.sql and had to run it in our database management software. It can be difficult managing multiple SQL files, and it's hard to remember which ones you've already applied. Also, if you want to undo your changes, you have to create an additional file or use your database software to manually undo the changes. That's where migrations come in. We'll learn how to create a table to store our monster's favorite cuisine. Open up a terminal, SSH into your Vagrant box, and as usual, change to the application root. We'll use the create action of the migrate command in order to generate our first migration. This accomplishes several tasks. First, it creates a database table called migration, which will be used to store your migration history. Secondly, it will create a migrations directory in your application root if one doesn't already exist. Finally, it will create a file in that directory, which contains scaffolding code that will simplify the process of writing your migration. In order to accomplish this last step, we have to provide a name for our migration as a command argument. We'll call ours add cuisine. Now, switch to your code editor and open the new migration file. The up method will execute when you apply your migration. So here's where we'll do our alterations. First, we need to create a cuisine table. For that, we'll use the create table method. The first parameter is the table name. It uses a double bracket and % in order to tell you to properly quote the table name. Next, we use an array of column names as well as their data types. If you look at the use statements at the top, you'll see that we have this schema class. This class has some constants that we can use to easily define our data types. The ID column is a primary key, and the description column is a string. The PK type will automatically cause the column to auto-increment, and the string column will convert to a varchar with the length of 255. The schema class uses generic names for its types in order to help you keep your application database agnostic. The final parameter is any additional SQL that you want to append to the create table statement. We'll be sure to set the storage engine to InnoDB because we're going to create a foreign key relationship in a minute. First, however, we need to create a related key in the monster table. We'll use the add column method to do that. It takes the table name, the column name, and the data type as parameters. This will obviously be an integer. Finally, we'll add a foreign key with the add foreign key method. This takes the name of the index, the table and column names, and then the related table and the column name as parameters. Now that we've created our tables and indexes, let's add a little data. We can do that using the batch insert method. The first parameter is the table name, and then the second is an array of columns, and the third is an array of values to insert. Now, you can save the file, switch to the terminal, and run the migrate command. You'll clearly see that we've created our new cuisine table, complete with data, added a cuisine ID column to the monster table, as well as a foreign key index of the same name. But what happens when you realize after pushing this change to production that you find your users don't agree that they are what they eat, and you're forced to remove the feature? You can revert the code changes easily enough in your version control software, but deleting tables with foreign key indexes can be a real pain to perform manually. That's what the down method is for. The methods to reverse our changes are pretty self-explanatory. Each create or add method has a corresponding drop method. The most important thing in our case is to get the order right, or it will fail because of foreign key constraints. First, we'll drop the foreign key. Then, you have to get rid of the index, which was created when you added the foreign key relationship. Next, we can get rid of the cuisine table, as well as the cuisine ID in the monster table. At the end of the down method, make sure you return true so that ye knows that your migration was performed successfully. Save the file, switch back to the terminal, and run migrate/down. Look at the database again, and you'll see that all of our changes have been magically erased. The last thing to note is that you usually create a migration that corresponds to a commit in your version control software, and then commit the migration file along with your code changes. You can even create a hook in some version control software that automatically runs the migration command when new changes are pulled into your repository. Now, you've learned a much more organized way to manage database changes during the development lifecycle. In the next and final video of our course, we'll learn how to translate our application into multiple languages. This is the fourth and final video of the seventh section, Love, the International Language. In the last video, we learned how to use migrations to organize database changes. Now, we're going to learn how to translate our application into different languages. We'll configure our app to look for alternate translations when they exist. Then, we'll use the application's T method to tell Yi which blocks of text to translate. Next, we'll use the message command line tool to generate our translation files. Finally, we'll create a language-specific view, because sometimes it's just easier to simply translate an entire page rather than individual blocks of text. The first step is to open up config web.php and configure the source language for the application. We'll use the default value, which is en-us. The en stands for the language, which is English, while the US stands for the region, which is the United States. This might come in handy, for instance, if you wanted to tailor your content for users in the United States and the United Kingdom. Next, we'll change the language of our application. In this case, we'll simply set this to DE, which stands for German. Next, let's open up our monster model and add some translation code to our attribute labels so our German-speaking monsters know how to sign up and search. Simply wrap each array value in a call to the T method of the application object. The first parameter is the translation category. You can use this parameter to keep your translation files organized. We'll call this monster. The second parameter is the message to be translated. While we're at it, let's create values for our beginning age and end age labels, as well as for our image file, which was created when we learned how to upload a profile picture. Now that we have some content to translate, let's generate the message files. The first thing we have to do is create a messages directory in our application root. Next, we'll run the message command's config action in order to generate a configuration file for our message file generator. We'll tell it to create the file in our new messages directory. The message file generator will scan every file in your source path directory, which in this case is the application root, as well as all of its subdirectories, and try to find calls to the T method. It will then create files in your messages directory that you can use to translate your text content. Head back to the terminal and run the message command again, passing the config file location as an argument. In a minute or two, you will have message files ready for translation. Open messages, de monster.php, and you'll see that all of our monster attributes are just waiting to be translated. Fill in the German translations, and then save your file. The last step is to head back to the main config file and tell Yi where to find the translations in the monster category. Add an I18N configuration and configure its translations attribute. We'll create a configuration for all categories here. We'll tell Yi to use the PHP message source class, which simply means that our translations are stored in PHP files rather than in the database. Next, we'll set the base path of our message files. Then, we'll set the source language, and finally, we'll create a file map which links the message category to its corresponding message file. Save your changes, and then pull up the monster list page in your browser. You'll see that the search fields are now translated into German. You'll notice, however, that the profile information in our list view is still in English. That's because we didn't use the T method to output this text. We'll leave that up to you to fix. So now you know how to translate individual blocks of text. But what if you want to translate an entire page? It's actually remarkably simple. Using the setup we already have, let's translate the home page. Open up the Views Site directory and create a DE folder. Now, Copy index.php into that folder and open it. Replace all of your English content with German content and save the file. Much like the themes, a translated app controller will look for a translated file first and then fall back to the original view file if none exists. Congratulations! You've created your first application using Yi2. You created a development environment and installed the basic application template. You learned how to scaffold and test your code. You learned how to create users and log them in, as well as restrict their actions. Then, you learned how to change the appearance of your application. This led to the development of a search UI, which allowed your users to search for each other. Finally, you learned how to add some advanced features to your application. But you'll surely see that there's a lot more that you could do to make this application look and feel more like a real-world dating site. The next step is to take a look at the Yi2 Definitive Guide, which will help you dig even deeper into this incredibly flexible and powerful development framework. The Definitive Guide is located at www.yiframework.com/doc-2.0/guide-readme.html. Once you master that, you may also benefit from looking directly at the framework source, which is located at github.com/yisoft/yi2. And who knows, maybe when the monsters take over the world, they'll treat you just a little bit more compassionately because you helped them find love.